Good evening, everyone. We are starting the session now. So, first of all, thank you so much to all of you for joining the session. And welcome to all the participants of the 6-day online FDP program on generative AI fluency, organized by SSC NASSCOM and sponsored by AICTE ATAL Academy. This program will run from 6th October to 11th October 2025. I am Kamna Jain, working with SSC NASSCOM. It's a privilege for me to be the coordinator for this program, and it is an honor for me to initiate this orientation session. Before we start, let us take a moment to recognize the significance of this moment. I will begin with thanking AICTE for taking up this important initiative and entrusting us at SSC NASSCOM to host this program. I would also like to thank Dr. Abhilasha Gaur, CEO, ITES SSC NASSCOM, for encouraging and supporting us to put this whole program together. Thanks to her guidance, we have an absolutely brilliant set of resource people to guide you in this journey. Let me tell you a little bit about NASSCOM, which is the Association of IT Companies in India. We have almost 3,800 companies who are our members. We have been the voice of the IT industry for the past 30 years, delivering insights, hosting leading events, and shaping policies. Sector Skills Council is the skilling part of NASSCOM. So we are the national IT skills setting standards body for India, and working directly with the Ministry of Skill Development and working to skill people in IT skills and IT technologies. Now, Future Skills Prime is a collaboration between the Ministry of Electronics and Information Technology, which is METI, and NASSCOM. This initiative was launched by Prime Minister Modi himself, and today we are offering courses in 11 emerging technologies and soft skills. The course which we are going to do now, which is Generative AI Fluency, is provided on the Future Skills Prime platform, where we have created a group for you. Every day, different topics will be covered by our experts, and all the participants need to complete the same modules on Future Skills Prime. So I'm very honored to share with you that we have the most eminent resource people who will be guiding us in this journey. We have Dr. Puneet Agarwal, who is the CTO and co-founder for Rocket Frog AI, based in Delhi. We have Dr. Gopal Tadapalli. He is a subject matter expert and ex-faculty, Anna University, Chennai. We have Mr. Akbar Mohammed from Fractal AI, who will be joining us to tell us about Gen AI in pharmaceuticals, healthcare, and mental health. We have Mr. Srijit Nair, who will be joining us to talk to us about OpenAI tools, DALL-E, Midjourney, and other AI writing tools. He will also be taking another session on everyday uses of Gen AI, which includes language translation and resume writing. We have Dr. Pramod Dasan, who will be joining us from Prague, Czech Republic. He's part of the DHL group, and he will be taking us through Gen AI in robotics, gaming, and automotive. We have planned all these sessions over the course of this whole week so that you can take the session and then complete this course on Future Skills Prime. I would strongly encourage you to engage with the trainers and put your questions in the chat box so that the trainer can see your questions and then help you with any doubts or any confusions that you may have. We have Dr. Prakash Guteti, who will be joining us from TechM Hyderabad, and he will be telling us about Gemini AI, generative music, and generative audio. Dr. Gopal will also be taking another session on October 9th. He will be talking about using Gen AI effectively in communication, presentations, and writing prompts. Mr. Rishabh Kumar will be joining us on October 10th. He will be talking about key ethical concerns of Gen AI and Gen AI in legal. Anjana Kanduri will be joining us from Netherlands. She is a subject matter expert in Gen AI in the retail, supply chain, and fashion industry. And then on Saturday, we will be having sessions from 2 o'clock onwards. You can use, we will be sending you a separate link for that. For all of these 5 days, Monday to Friday, please join in the same link. And on Saturday, the sessions will start from 2 o'clock, and I'll be sharing a separate link in the WhatsApp group where you can join. On Saturday, the first session will be taken by Dr. Harshal Shah, who is the Dean of the Engineering Department at Parul University in Goa. He'll be talking about Gen AI in real estate, architecture, and interior design. And the next session will again be taken by Dr. Prakash Kotetti, TechM, Hyderabad. On Saturday, we will have 3 sessions. So the third session will be by Shikha Tyagi. She is a subject matter expert in tools for online learning. She'll be joining us from American Express Gurugaon. There is the information. I would like to also share some important information for the participants. I request you all to sign up on the Future Skills Prime platform. We have already created a group for you, and you need to complete the course Generative AI Fluency before taking the assessment. On completion of the program, there is an assessment which is going to happen. That will happen on Saturday, and the assessment will also be online. We will be sharing the promo codes with you, and you can use those promo codes to take the assessments. Some of you have asked me that there is a assessment for 600 rupees, but that will be free for you. You just have to use the promo codes which will be generated on the website, on the email ID with which you have registered on the AICTE ATAL portal. I would like to remind you that you need to have an attendance of minimum 80% and score more than 70% in the test to get a certificate from ATAL Academy. Feedback must be shared by the participants through AICTE portal, which is available on your logins. If you do not fill the feedback form, then you will not be able to get your certificates. To tell you a little bit about SSC NASCOM, this course has been curated by industry. So what we have done is we work with the members who are our members like top IT companies. So you have Microsoft, Cisco, AWS. We worked with them to put together this course. And then what we have done is, if you explore the Future Skills Prime platform, we have courses on 11 emerging technologies and also on soft skills. So I'd also request you to explore the portal, Future Skills Prime portal, and you can share it with your students as well. How we identified these top emerging technologies is we worked with BCG, which is a consulting firm, and asked them that which are the top technologies which are going to change the world or which will be most in demand. And then they came up with 11 technologies, which includes cybersecurity, IoT, artificial intelligence, AR, VR, RPA. So we have courses from all the original, the leaders in IT. We have these courses on our platform. And I'm very happy to share that this generative AI fluency course also covers all domains, because as we know today, there is no company which is not an IT technology company. All the students who will be joining the industry, they may not get a job directly in the IT industry, but whatever industry they go to will be an IT company. So you take your Swiggy, your Zomato, WhatsApp, Instagram, Facebook, all these are not IT. They are all being run by IT companies, right? All of them have some IT component to them. And there's a question which Amit Kapoor has asked, that we have to do the same on Future Skills Prime portal. Yes, please complete this course on Future Skills Prime platform, because the necessary conditions for the assessment are you need to complete the course on Future Skills Prime platform. You need to attend all sessions. Minimum 80% attendance is compulsory. In the test, you need to score 70%. And only. And then you also have to give your feedback on the AICTE ATAL portal. Once all these things are completed, only then you will be getting the certificate. The certificate generation will take some time. It's AIC, so we will, please allow us some time. It will take a couple of days, maybe a week or 15 days for the certificate to get generated. So I'll request you that once you finish the course and you take the assessment and you clear the assessment and you fill in the feedback form, which is provided uh, on the AICT ATAL portal. You give your feedback, and after that, 15 days after that, the certificate will be generated. You can put your questions to me in the WhatsApp chat. I'll be happy to answer all questions. Dr. Sneha Bora has asked that can we do this course self-paced? I mean, within this week? Of course, ma'am, you can complete the course. Since it is a self-paced course, it will be helpful if you can complete the course even before coming for the sessions, because you'll be in a better position to ask questions to the panelist, to the speaker, because you will have a basic understanding of the concepts which will be available on the platform, as well as which the trainers have also prepared slides. And I'll encourage you to engage with the trainers, because these are the best people in the industry to help you understand the concepts and take the knowledge with you, which you can then share with your students. If Dr. Soumya couldn't find the course in Future Skills Prime, ma'am, I'll request you to, if you have logged in, you have registered on AICTE portal, we have created your group. It is called AICTE ATAL Generative AI Fluency. That is your group. So on the Future Skills Prime platform, I can show you, one second. I'll just show you the, give me a minute. I will share my screen. I'm just showing you where the course is so that you go on the Future Skills Prime platform. Just give me a moment. I'm going to show you how you can access the course also. I hope you can see my screen. Here you, once you log in, you will see this tab of groups. So you go here, go in groups. There is a group called AICTE ATAL Online FDP Generation. Please visit this group. AICTE ATAL Online FDP Generative AI Fluency Participants. As you can see, the group has been created for you. You can go here. You will get a course, Generative AI Fluency. You can just directly go and get started. This will show you all of the modules, and you can complete this at your own pace. So I've already started this course, and I've also completed a significant part of this course. I'll just stop sharing. I hope this is clear. So as you see, I've shown you the complete journey to access your course. We have created your group. I would urge you to just visit the portal and sign up and then complete this course. Our next, I'm now going to just see if our we have the first session by Dr. Puneet Agarwal. I will just ask him to join. I think Puneet ji has joined, but I think he has not joined with it. Just give me a minute. I'm going to make him the host. Just give me a minute. Yes, you have to complete both future skills and the ATAL live class. Yes, 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 yes. Hi, Puneet ji, you've joined. Thank you so much. I was just waiting for you. I will just give me a minute. I'll introduce you and then we'll take it forward.
Sure, sure.
So, Ishwarya has asked if we have to complete both future skills and ATAL live class. Yes, we have to complete both the things. Susan ma'am, this recording will be available on YouTube. You can see the process, how we can get the course. And all of you would have got a welcome email from Future Skills Prime. You need to sign up and you will be able to access the course. And this recording will be available for you to see that. The direct link of Future Skills Prime. Okay, I'm just typing that over here. Just give me a minute. If you have not registered on the ATAL website, you will not be able to, then you will not be part of the group. If you have registered on ATAL and still not able to see, please WhatsApp me and I will make sure that you are part of this WhatsApp group, as well as you have login created on the Future Skills Prime platform. So coming back to this course will provide a comprehensive understanding of generative AI intelligence, its applications, its impact, and ethical considerations. You will get to explore the fundamentals of generative AI technology, its real world use cases, and its potential to transform different sectors. And with this, I would like to welcome Dr. Puneet Agarwal. Sir, thank you so much for joining us. Dr. Puneet Agarwal has worked in the IT services industry for 26 plus years. He has worked as CTO of Zensar Technologies and as principal scientist at TCS Research. At rocketfrog.ai, which is his own venture, he has set up a research lab and mentors a community of deep learning scientists and experts who are eager to make business impact via novel use of technology. Dr. Agarwal has experience of working in multiple verticals such as BFSI, fashion, e-commerce, consumer services, high tech and manufacturing, life sciences, governments, utilities, shipping and logistics, telecom, etc. He has published 50 plus research papers in IEE, ACM affiliated conferences, deep learning, natural language processing, knowledge graphs, time series, and software engineering. He has also filed 30 plus unique patents, which resulted in 200 plus global patents when replicated worldwide. Wow. He served on the program committee of reputed conferences such as KDD in recent past. He has a PhD from IIT Delhi in the area of knowledge graphs, NLP, distributed parallel processing, and deep learning. Wow, impressive. So I'll encourage all participants, please listen to him carefully, please engage, please put your questions in the chat box, if in the question box, and over to you, Dr. Puneet.
Yeah, thank you, Kamna, for such an elaborate introduction. and I'm so delighted to talk to all of you today. I hope you can all hear me clearly.
Yes, yes.
Thank you. So let's make this session as interactive as we can. I am using 2 monitors. So if you type any questions, I'll be able to see the questions as I speak. Making the session interactive is a key thing, because I plan to learn from all of you as you ask questions. You will force me to think and answer. And that's really what I'm here for. That's my takeaway. When you ask questions, I will learn something. So let me try and share my screen next. Okay, where is my, it's here. I hope you can now see my screen. Can somebody confirm? Kamna, can you see it?
Yes, we can. Yes,
All
we
right,
can see.
I'll get started now then. Good evening, everyone. Today, the topic is the generative AI. And I've taken a liberty to talk also about agentic AI. And this is a key ask from our customers these days in the industry. And I will cover some of the high impact business use cases as we observe them in the industry. So here is the agenda for next 1.5 hours. There are a lot of slides. If you don't want me to cover all of it, please ask ample questions and encourage discussion, like I said earlier. But overall, we'll begin with generative AI first, cover the basics. I will go a bit faster on the generative AI side and delve deeper in the agentic AI. I've deliberately kept mathematics out of it. As I know, you're all experts in this. I've focused more on the business side of it, or the business applications side of it. With that, let me begin with some little mathematics that you all know. There is a famous Bayes rule in probability. You see that in the top of this screen. And that's really what shows a discriminative model. What that essentially means is, given details about an artifact, maybe a photograph, which is X, the features of the photograph, the ratio of skin color versus other colors, etc., can give us a description of that photograph, and then we can take a decision. For example, boy or girl, human or animal, etc. Generative model, on the other hand, are very different. Here, they are driven by joint probability distribution of the features of the artifact at hand. And from that, we can sample, once we have the generative model, joint probability distribution, we can use sampling techniques to sample the data. That's all the mathematics is, nothing more. And that forms the basis of generative AI. So based on joint probability distribution, probability of X comma Y. So for example, we can learn the JPD of students in a class based on gender, mother tongue, height, skin color, hairstyle, etc., and generate new class, which looks somewhat like this, which may not be real. Here I'm showing you the photographs. We can even generate names of people, students, based on similar things as we saw in the left-hand side. So the question is, can we create the data of a new class Will this be similar to the original class? Yes or no? Actually, no. This will be different from every time we generate, it will be different. Will this represent a typical class? Probably yes. Every time we generate data, it will generate new students, new teacher, new stuff. But as per these traits, if modeled using these traits such as gender ratio, mother tongue of every student, height, skin color, hairstyles, what will happen is every time we generate the data with respect to these traits, it will be very similar to the original data on which this model, the joint probability distribution, was trained. And this is called a generative model in machine learning and forms the basis of all the modern generative AI. I'm sure many of you must be familiar with all of this, and therefore I ran a bit fast. Now let's proceed to observe what are the problems in this approach. You see some problem here? On the left-hand side, there's a new image. This comes from India. You see the right-hand side and the left-hand side is very different. So what's the problem? When they try to train these things, if you generate these photographs from popular image generation tools, whether it is Google Gemini, ChatGPT, or any other popular image generation algorithm or API on the web today, you will observe, unless specified, it all by default generates the one similar to the right-hand side, not the one similar to left-hand side. And they try to cover all ethnicities, countries, cultures, etc. in the training data. They cover all of it. But the question is, will they be able to cover all the attributes? No matter how huge the training data is, they will always miss out on something. And this forms the problem, the genesis of the problem called bias. I'll take some examples of this bias. When we generate a worker in an oil rig, will it show a woman? Probably not. When we ask it to generate a teacher, will it generate a man? Probably not. As you can see in the photographs, I did not specify the gender of the teacher. By default, it chose female in this case. When we ask it to generate a photograph of a class, will it generate from India? It doesn't. And that leads to bias. Sometimes such bias gets introduced inadvertently, and we have no other choice but to live with it. We are not even aware. And probably because there is inherent bias in the real world also. So that's really what was the introduction to generative models and the challenges. Next, I will talk a bit about LLMs, how LLMs work. I think my animation has gone out here a bit. Let's look at this sentence. Tree, one jumped, another from elephant two. I know it doesn't mean anything, correct? If I use this sentence, the choice of words are same. Elephant jumped from one tree to another. The choice of words are same, just the order is different. And what is the likelihood of the sentence 2 being right versus the probability of sentence 1 being right? Naturally, you will say the sentence 2 is more likely. But do elephants jump from one tree to another? Actually, monkey can jump from one tree to another. And therefore, probability of the sentence 3 happens to be more than the probability of sentence 2. And that's how we train a large language model on a plethora of natural language sentences like this, taken from real world. And that, when trained on really large computers, really large GPU machines, on a very large corpus, has, in a nutshell, have given us the large is really large there, language models. Now let's look at the use cases of generative AI and then LLM. Mainly, these will fall in the basket of, I will say, amplifying human performance. For example, document summarization. In the industry, we receive a lot of requests for proposals. When a customer needs a project from us, in the services industry, in the IT services industry, they send us an RFP. Oftentimes, these RFPs can be long as more than 50 pages and a few hundred pages also many times. It takes us long time to read that. Can we give all of it to an LLM and ask it to summarize for us and understand it in no time? I have spent days reading such RFPs in past. Sometimes 2 days, 3 days, 5 days, every day few hours reading the RFP, trying to understand what the customer needs. But now you can spend just 1/3 or probably 1/4 of the time that we spent earlier. And the system will just summarize and help us make sense out of it in no time. So much so that we can even ask questions to it. If there is some section that we are not able to understand, it will summarize it for us. Similarly, financial report summarization. It used to take whole day to read a report for financial economists and finance analysts. You can read that very fast now. Academic research papers, I'm sure so many of you being from the academia. I remember reading a paper, one research paper in deep learning, minimum 2 to 3 days to read end to end. Not anymore. We give those papers to ChatGPT or another LLM, which will summarize it for us in a few hours. We get the gist of it, what we want, with details, with all the mathematics involved. I even remember times when I spent more than a week and sometimes even 10 days to read a research paper. So that has gone. Generate quizzes. I'm sure you're already using that. And I'll just give you a very simple example. I have a young son. To give him a practice for mathematics test, I don't have to buy books. I just give a topic and it will generate 20 questions. That's all. And I can even specify the hardness level. I can give sample questions from the textbook and ask LLM to generate these test case sample quizzes. Generating images for various purposes. I'm sure you must be already doing all of it. Presentations for some of the images that you saw in this presentation, those kids in the school classes were generated by an LLM. We are seeing so much of usage of generated images in social media and many more purposes. Creating such images was a mammoth task until this technology was there. Leave alone images and documents. Here comes software programs. They get generated by LLM. And I'll be very frank, and I will tell you, it comes a little later. First, Not only programs, when you write programs, you need to test them. Test cases get generated automatically. How to test it? That used to take months for quality assurance team to generate or to write test cases. Now they get generated in no time. All they have to do is just review it and give some suggestions or additional prompts to the LLM to fine-tune those test cases. If it has missed something, it has overwritten some part, you can ask it to compress it, etc. But as they say, everything is not so good. Vibe coding is a new paradigm in software engineering. What is vibe coding? People using LLM to generate that code. And I, as a founder of a startup, I will tell you, I'm a victim of vibe coding. What happens is, so many young people in our company, and not only in my company, everywhere, they use LLM to write code for them. They're very fast. Had you written that code manually yourself, it would have taken you 2-3 days. That you can finish in few hours. But what's the problem? Why do I say I'm a victim? It's because oftentimes the generated code is not human understandable for many reasons, such as the variable names are not intuitive. It will use very complex language constructs. Things like very complex list comprehension in Python. They are so hard to read that anybody can spend half an hour to 1 hour trying to understand 10-line program. As a result, people don't read those programs. They don't understand. And they push it in. They say that it is, and because the system works. Effectively, what's happening is they're not actually learning programming. And we are being more dependent on the LLM. We had to bring in special practices within our company to safeguard against such potential threat by vibe coding. In fact, now, every time any developer writes any program in my company, we check it against another agentic AI solution, which will not let them proceed, let them push that code into GitHub until some basic coding guidelines are followed, and which are not normally done by vibe coding. And that is the only choice we have left. Because this code that is written by LLMs can only be read and understood by LLM only. Human cannot. Is this a trap? People, when I say some things like this, people also ask me, so is it like the AI is trying to throw a net and going to trap all us human beings such that only it will write the code and we will not? Well, probably yes and no, both sides. We have to be careful ourselves. And I would really like to have opinion from all of you. I see many messages, so let me start attending some of them. Okay, yes, okay.
The logistics questions I will take separately. Dr. Puneet, you can please focus on the content part only.
Sure. I see that there is somebody saying, if possible, share screen and explain. Can you not see my screen?
I think what they mean is the vibe coding thing, because we can see your screen,
Okay.
Probably the vibe coding part is, if I understand
Well,
correctly, they are.
I haven't included examples. I will give you top of, since you've asked, let me give you top of my head examples from an LLM. If you have a dictionary, and dictionary in a Python program is often comprising of keys and values. And if the variable name is also key and value, how do you read that program when it is written? That this is my dictionary, the key is key and the value is value. When you start reading it like that, it gives you a cognitive overload and you're not able to read the program. However, if the program was written like this, that the key is my key and the value is a string, and the variable of that is the in which it is stored is called my value. That is much easier to read. Therefore, and I have seen, you would have seen yourself, if you write programs using LLM, it generates very high quality code in terms of quality and error free and very good, but hard to read and hard to maintain. Recently, I went on LinkedIn to make a post to say, you will find that post on my LinkedIn page of how I struggled when something was not working a few months ago. And I plan to come up with, write a paper on this, what kind of coding practices that it leads into. I'll cover more of this in detail in coming weeks, but I'll just, on this talk, I'll proceed without more description. Generative AI can also assist us in writing nowadays. So many youngsters, we in India do not remember the rules of grammar so well in English. Now they can write the sense of what they want to write, give it to the LLM, which will regenerate the sentence in perfectly well-formed English sentences without any challenge. That's another use case. And therefore, we say expertise in language is not a barrier anymore, at least in the written skill. Another very big advantage is when you want to do anything. For example, if I were to deliver a talk like this, I asked LLM that I want to deliver a talk. What should be the content? It gave me first version, key topics that I should cover. I would customize it based on how I want to, but it gives me first version, and it helps a lot in thinking because you're not starting from a clean slate. You already have something. Somebody has done all the thinking for you. And that's another benefit of let me now proceed to more unexpected type of what I should say, use cases of generative AI, not so well known. Let's say we have an ERP system, such as core banking system. I don't know if you're aware. One of the most popular in India are by Infosys called Finacle. TCS has a TCS Banks and many more. Likewise, in the insurance industry, there are many ERP systems which are core insurance systems such as Guidewire, Magenta, so many. And every bank in the world will need a system like this for it to function. But that bank, that software is a vanilla software. You need to customize it based on your bank's or processes. For example, you need to input all your fixed deposit rates, what you're offering to the people, all your products, all financial products, credit cards, savings bank account, current bank accounts. Similarly, in the insurance industry, you have so many insurance plans and policies, you need to input all of that data into the system. Only then can it process and start giving insurance to various people. And that's really how industry works. So that with that as a background, the question is, if I want to introduce a new policy in the insurance company, how will it affect my current customers? Can I study? How do you do this? We need to generate near real, almost real data of actual consumers who have actually bought insurance or following the rules of demography. That in the geography where you're about to launch it. And in fact, the question I will ask, you should ask, or you can ask me, is that this is already being done using data masking. That is, the data is already there in production. And they have the data of real users already. Why can they not reuse the same data in the development environment also to check how will the customers behave under the new policy? How many of them will take what, will fall under what bracket in terms of eligibility criteria, etc. Why do we need a new solution? I'll appreciate anybody who wants to share any thoughts on this, that what's wrong with the data masking. The problem is that you have a software, you have real data of real customers. Can you not take the same data and bring it to your development environment and use that for testing? And you can mask the personally identifiable information of people names, their gender, age, etc. that you can randomize, and rest of it can carry. It's important to think for a while before I jump on to the answer. Well, the problem is that it will give you a lot of spurious data. If there are more people in the age bracket of 40 to 50 who buy insurance, when you carry the data from production to dev, you have to carry all of it. It's hard for you to filter away the data. All you need is variety of the data, not volume of the data. And therefore, generative models are very, very useful. That is, you can train a model that learns the traits of the data from the production environment, and at the time of development to test your software or configuration time when you're trying to configure a core banking system, you can generate data that is not real, but realistic or typical data, or as near as possible to the real data. This is a very common ask by many large banks to us. Another very interesting use case of generative AI is data validation. When I write a document, I want any document that goes out of my company to my client or other stakeholders, to my partners, I want them to follow certain minimum quality standards and branding guidelines. If I were to review everything myself, it's hard because so many documents go. Can there be an agentic AI solution that can review and give a score on the compliance of the corporate guidelines? And that more or less brings us to the end of a discussion on business use cases of generative AI. I'll be very happy if you have any questions or you have additional use cases to share. While I leave you with a question that will come back to us later again, how to test the conversational systems. When you build a modern AI chatbot, how to test that? I'll leave you with a question, not giving an answer at this stage. So this is a logical end. Before we move into agentic AI, I'll appreciate, let's take a quick 2-minute break. And I will appreciate if you people want to ask questions. I'll be happy to answer them and just have some discussion before we move forward to the part 2 of this talk.
Is there any questions from anyone? Please put them in the question box. We are getting some questions on attendance that is tracked automatically on Zoom. So just clarifying that for everyone.
Or if you want, I can ask some questions.
Sonali is saying, yes, sir.
Yes, I should ask. I want you to share innovative use cases of LLM that you have tried in your life yourself, that you think are not covered here and you want to share with us of what you have tried and you did not imagine that it is possible, but you found it to be possible.
We can give them some time to think and come back with the answers if you want to move ahead.
All right. Sure, Kamna. Let's move forward.
Okay, we are getting some answers.
Very interesting thought by Dr. Sneha, the converting the data in English to regional languages. The very, very important point, ma'am. You're right. However, there are many open challenges yet to be solved in the language translation side. A great work is being done by AI for Bharat and IIT Madras initiative. For example, when we want to process these languages using deep learning, we need language normalizers, language tokenizers, etc. And such tokenizers were not available before this. There were no data sets available at all in any other languages. So I wouldn't, while it art of possible is still there, but a lot of work needs to be done in terms of translation to lesser known, or I will say low resource languages in India. Low resource as in the languages for which there is not enough digital annotated data sets available. All right. So that's really what my view will be about language translation side of it. I'm getting some very interesting questions. Let me take a few more. Google Translate does a great job indeed. That has been the, I think, the number one for many years. However, when you want to do document translation, when you want to do this at a large scale, when you want to do live, and that too in regional languages, low resource languages, not everything is so good. Let's proceed forward. There's some interesting questions coming up. Generating lyrics from contextual prompts. Very, very nice. Some Deepti is sharing. Yes. There were some tests done a few years ago about the generated music, and they generated symphony for some 3-4 tracks, and they gave it to music maestros, and they were asked to identify which one was real and which one was generated. And guess what? They could not. I'm sure you must have read that in the news. So yes, generating music, lyrics everything is so interesting these days. Dr. Buddy is asking for a difference between LLM and SLM. A very, very interesting question. So the LLM and SLM and the use cases of SLM. Okay. So imagine that you these days, for many purposes, for many of our customers in Rocket Frog, in my company, many customers tell us that they don't want to use the publicly hosted LLMs such as ChatGPT, Gemini, etc. They want to use a local LLM installed on their own GPU machine, such as, because, and primary reason is they don't want to take a chance of their customers' data or their confidential data going out to the outer world. They don't even want to take a chance. It's super confidential. In a situation like this, imagine that you have installed a large language model. For example, ChatGPT has come up with OSS GPT 70B, 70 billion, pretty large in size, a very large model. It can, and imagine, let's try to imagine a scenario that this LLM is being used by, let's say, a bank. But let's understand this LLM is an overkill because it can answer questions about animals, biology, pedagogy, any this art of software writing, etc. And so many fields, medical science, space, robotics, whatnot. But that LLM is being used by an application for carrying out specific tasks. So the question emerges is, do we really need that large a language model? The counter argument that you will make is, it is that surrounding knowledge which gives this LLM a power of what we call as common sense. If we use a small model, which is smaller in size, it will not have as much of a common sense and reasoning capability. And therefore, we want to continue to use a very, very large language model for every small use case. Well, that also does not make sense. When do we use SLM in that case? So the best practice that we follow is have a large language model in the beginning, run the solution in production for about 1 month, observe that what is being actually, how much of knowledge of the LLM is actually getting utilized, and then carry out a process called knowledge distillation and learn a small language model that is much smaller in size in terms of gigabytes of memory it will take. It can run on a smaller GPU machine, much cheaper, can sustain many more parallel users. In terms of performance of these LLMs, how we measure them as called token per second, called TPS. A typical machine of ADA family can give us order of 50 token per second kind of throughput when you ask a question to the LLM on a personal machine. Now, if you distill the knowledge and make it much smaller, you can even go for 200 tokens per second on the same computer, on the same GPU, and the quality will not go down. And that's really what, real world use case of SLM I wanted to share. And I hope that answers your question, Dr. Betty. Have I announced your question clearly? Thank you. Can I know which can't be generated by AI machine? Very interesting question, Subhash. Very, very interesting. What cannot be generated? So I think today almost everything can be generated, but it's all about quality. And I will please hold this answer, Subhash. I will hold this question in the remaining part of the talk. I will answer it with more context. I will remember it. I'll give more color to it as to what becomes hard for LLM and AI to generate and how do we mitigate that. In fact, you're helping me go into the next part of my talk. So this is a very good question. I'll just park it for a while. Created micro using ChatGPT by giving very interesting use case being shared by Sonali that created micro lesson plan using ChatGPT by giving correct prompt and submitted within few minutes. Something very interesting. With that, I think we spent good 10 minutes on question answers. Let me proceed to the second part of the talk as to what is agentic AI. So far, what we learned was generative AI. And now we're going to contrast as to what is the difference between generative AI and agentic AI. I'll appreciate if people want to share their thoughts on this in the chat window. There are many complex organizational workflows, often called as back office processing. And they take inordinate amount of time. And we will see examples of some of them. So much so that some things we don't do in practice. An example is coming up. So agentic AI is an autonomous program or a system that are goal-driven. They create a roadmap for themselves of how they will carry out a task and plan and create a plan for themselves. And then they try to follow that plan. And if it is a 5-step plan, they will execute step 1 and then come back to the planner and check that should I replan things based on emergent facts, because I've carried out step 1, I know more than earlier. And it replans and continues to proceed forward in the plan until it finishes and actually acts. And sometimes has iterative or process or cycles. I've tried to use an acronym out of it called GRACE. Goal-driven, has a roadmap, acts, has cycles, and is an autonomous agent. And because it can think on its own, plan on its own, execute on its own, access other resources, and carry out a task in an autonomous manner. And that's really what is agentic AI. Another interesting fact about agentic AI that it can use external tools. Enterprise systems such as database, it can go and query a document library, find out the rules, and then plan and then go forward. It can coordinate with multiple specialized agents and can also learn from feedback. Doesn't it sound similar to us, the human beings? And that's really what agents of automation are called as. So this is a kind of perspective that I've come up with, if I were to describe this in short, autonomous agents that can execute a complex corporate or organizational workflow, which otherwise takes very long time and many people to coordinate and complete, and can be done in almost no time with these multiple agents. And that's really what is going to change the way the world around us in coming years. Because to be very frank, in my company, most of the projects are on agentic AI from customers. What we are building for them, someday or the other, it'll come back to us as a consumer and we will start using them. The world is expected to change great bit with the introduction of agentic AI in the systems around us. There is an assertion by Sonali, generative AI generates outputs that resembles the data it was trained on. Agentic AI acts on agent that can think, decide, and do. What a nice thought, Sonali. You're right. It generates the data similar to how you trained it. That's generative AI. And you leverage that generative AI to build agents such as those described on this slide. Let me move forward from a real use case. Imagine a hospital. And this is our coming from a real world a customer that we have in the US. And the problem was that we want to take patients, their papers. Can we upload all of those papers and create a patient history summary in no time without it making any mistake? That has become possible now. It can save time of a senior doctor a great bit. We did this in a limited capacity of mental health disorders. So how do we, there is a question here. How privacy is taken care of in case of agentic AI workflows? What a nice question, Chandra Kumar. Chandra, very nice question there. So like I was trying to describe to you, the first thing that we normally do is in the corporate workflows of agentic AI, they don't use publicly hosted LLMs such as ChatGPT, Gemini, etc. They use open source version of these LLMs, install on their own computer so that none of the customer data goes out. For example, banks, insurance companies, and so many others, even healthcare, the system have to be compliant with HIPAA. The systems have to be compliant with GDPR, and customer data is never compromised. And that's where we help. We help set up our customers a local LLM for their own purposes. So, and there are many more such, what I should say, measures or guardrails that we create to ensure the customer privacy in this case. Sahil is saying, what does psychiatry fine-tuned LLM means in this context? So what we can do is, while there are LLMs that have emphasis on medical data, and some of them are already released, you can check yourself. And in this case, our customer wanted to fine-tune an LLM that is particularly trained on data from mental health scenarios, from the sessions of psychiatrists from their patients and fine-tune an LLM that has more know-how on that area as compared to the general system. So that's really what fine-tuned, psychiatric fine-tuned LLM would mean. Now let's look at the technology stack on this slide. What you see on the left-hand side are called low-code, no-code, LCNC platforms. If you go to make.com, they will let you create a graph of prompts, and every prompt can connect with another prompt, etc. And the output of the previous prompt goes into the next prompt. And every node is a small compute, and it can access database. It can call other agents, and you can pretty much draw and build an agentic AI solution without writing any prompts. And that's really what is low code, no code platforms are. Azure has recently launched some of these called Logic Apps, and there are some more. I forget the name. Amazon Bedrock Flows, Einstein Copilot Builder. Another very famous low-code, no-code platform is N8N. You can try some of these yourself on the net. However, as I said, they are done without writing programs. So they have limitations. They make assumptions. They don't give you complete flexibility on how do we change the agents and agent behavior? How do we program it? So there are platforms such as LangChain, LangGraph, one of the most popular platform when it comes to building agentic AI solutions. Crew.ai, Agno, Strands agents are recently launched, and they are also getting very popular. LiveKit is used for voice-based bots or voice bots. That is, you can talk to them just like a normal human being. 11 Lab provides us huge and one of the most stable libraries that can help us build agentic AI solutions. So that's a typical technology stack. If you want to play with it yourself, I thought of introducing this. But that introduces a problem. And that's really what we'll talk about next. We've talked a lot about the business use cases, etc. Let's take a bit of a deep dive into what happens in this case, in the agentic AI. So let me begin with a very brief introduction to prompt engineering. I'm sure you must have heard about zero-shot prompting. That is, we write a prompt and it gives an answer, normal prompts. But sometimes it is not able to give you the right result as you expect. In that case, can you give an example that here is a sample input, here is a sample output. Now for a new scenario, here is a new input, create a new output for me. That's one shot. Few shot. In the same prompt, instead of giving one example, you include a few examples. And it is well observed by everybody that the LLMs give you much better results if you start using few shot. And that was a very short tutorial on prompt engineering, on basic prompt engineering. But let me get into the little more advanced forms of prompt engineering. One of them is called chain of thought. And I'm sure many of you must have tried this already. It's a very popular technique. What happens in chain of thought? It's a prompting technique where you give multiple steps to the LLM and then arrive at the final conclusion based on the multiple considerations, multiple paths, that first do this, then do this, then do this, then do this, and then what you get is what you give me. And that is called chain of thought. Here it is shown with an example, with a diagram, that you may have a chain of thought. It's one prompt. Let's understand. The one which is in the white background is one prompt. And those in the green boxes are multiple thoughts. As part of single prompt, you are giving multi-step process. And that is called chain of thought. A very similar one is called thought chaining. What do you do in thought chaining is you include multiple thoughts in the same prompt, but you chain multiple such prompts. A typical complex agentic AI workflow is more like the thought chaining rather than chain of thought. And I remember somebody asking me a question, what is the limitation of LLM, what it cannot generate? Let me tell you, it's very, very easy for you to try LLM and it would not work. You know, this chain of thought, the best of the LLM available today that I have tried in my lab or my team has tried cannot think more than 5 steps. It starts to mess up. Maximum 5-step chain of thought, this chain of thought. Like this diagram has 6. I seldom observe that 6-step reasoning they are able to do. They are not. 4 or 5 is where it breaks. Depending on how complex the problem is, sometimes it will break at step 3 itself. And it starts to hallucinate. It skips some of the steps. You tell it to follow certain instruction, in the output it will not follow, etc. Many problems. You know, for example, you're all coming from academic background. I'll take example of a project that we were building, and it's coming in the subsequent slides. We wanted to create an e-learning course from a PDF. For example, for K-12 education. One of the primary fundamental of doing that was, we wanted to first, from the given PDF, derive course objectives. Then identify the topics covered in that PDF. Then group those topics, that I will teach these topics together in one slide, and then these set of topics together in the next slide, etc. And then you ask it to convert that into bullet points so that you can convey the message to the students. And then you tell it to follow Bloom's taxonomy. I'm sure you're all coming from academic background, and I don't need to tell you what is Bloom's taxonomy. But even then, if some people don't know, it gives us a right framework when to use the word explain, when to use the word describe, when to use the word analyze, when teaching things to students. They're not, and I'm sure you all know that. I'm preaching to choir because you're all teaching is your primary profession, and you would know that better than I do. And when to use what word. And that's really Bloom's taxonomy does. In the whole sequence of steps, like I was trying to describe, step 1, identify course objectives. What you want to teach to the student. Step 2, group the topics. Step 3, for every topic, describe the bullet points. Step 4, for every bullet point, ensure compliance with the Bloom's taxonomy, etc., etc., etc. If you try to do it, it will break beyond 3 steps. It doesn't work. You try it yourself. Now let's go to thought chaining. What you do is, because multi-step reasoning does not work, you divide that in 3 prompts, for example, like in this case. But the problem there is a basic mathematics. Yeah. Imagine that each of these prompts is giving you 90% accuracy. Right? Like in this example, there are 3 prompts. So the output of the first one goes into as input to the next one, and then the output of the second goes to as input to the third one. If each of them is giving you 90% accuracy, What is the overall accuracy of the system? 73% approximately. That is 9 cube. Straightforward. And what if you have 5 nodes? You talk about 0.9 to the power 5. So the accuracy continues to diminish. More agents or more nodes do you use in an agentic AI solution? And that is what makes the agentic AI hard. Any thoughts on how do we solve this challenge? I'll appreciate it. While I read some questions from the chat.
We have 2 minutes left for this session.
Oh, is that so? So
Yes.
I'll try. I was thinking it is 1.5 hour long somehow.
Oh yes. My bad. It is 1.5 hour long. Sorry, my bad.
So I have 30 more minutes. That's how
Yes, yes, yes.
So I'm
Yes,
not
yes,
doing
yes.
bad on time.
No. I'm sorry. We started at 6, but that was the orientation. So 6:30 to 8 is the session. You're right.
Thank you. So I can continue in that case.
Yes, yes.
So I'll let people react to my question that how do you solve this challenge? You have multiple nodes in an agentic AI system, and they are bound with a chain, as an input of the previous one goes as output of the next one. And if each of them is giving you 90% more accuracy, then the overall accuracy will be very less, as a very simple math that I've shown on the slide. How do you solve this? Let me attend to the question that is there. I tried to generate a complex SQL for a defined field in Google Looker Studio. However, Gemini wasn't able to do so multiple times, even after describing it quite well in the prompt. Very well observed, Shubham. Very nice. I agree with you. It is not able to. You know how we solved it? We have a product in our company. We call it as talk to data. We solve it by using multiple prompts, by using a very specific topology of how various nodes are connected with each other and how do we solve it. It's not simple. In a single chain of thought, it cannot generate the SQL from a natural language sentence. It doesn't work. Very good example, Shubham. Chandra says, by giving example, how do you make sure that the accuracy is improved, the overall accuracy? See, no matter what, you're giving every example at every prompt, and every prompt is giving you 90% accuracy. You cannot change the prompt now. But all you have to do is just change them. And if you do that, the probability of the accuracy will continue to diminish as more prompts get included. Neural networks, more examples. Let me ask you another question, and this is a hint for the answer. How do we human beings solve? As a great philosopher said, to err is human. Every human makes a mistake. Nobody is perfect. And we human beings work in a team together, and we make a perfect solution many times. How do we do that? Can we learn from human behavior and train the AI in a similar manner? Learning from mistakes. Yes, you're getting there. You're getting there. But still not there. Teamwork. There it is, Deepali. I like it. Fantastic answer there. Can you elaborate? Somebody can elaborate. Teamwork is in the right direction. Criticizing. I mean, criticizing is a very strong word. I will say constructive feedback. Reward and penalty, Dr. Badi says. We share ideas, correct each other's errors, and come up with better and more perfect solution. There you go. Can we have one prompt that is doing the work? Can we have another prompt And the responsibility of the second prompt is to review the output of the previous one. In back office processing, in BPO industry, there is a very famous saying called maker checker. There is a human who does the work. There is another human who checks the work. So can we make these two humans work against each other? That's really how the manager does. They gamify. A manager in a typical corporate setting will bring people of multiple skills together in a team and make them work in a complementary manner. They bring different aspect, different skill, different perspective to the same problem. And as a team, we win. Can we do something similar over here? As a result, these numbers 0.99, they don't multiply, they complement. They don't become a limitation of each other because they complement each other. And that is how we design complex agentic AI systems. And this is a very important message when you try to implement any solution. When you design a solution using these technology platforms that I talked about in the previous slide. It's a multi-node, it's like a graph or network. But what is the nature of every node in the graph? You need to carefully define. And plan and replan, and then reviewer, everything. There are many papers published on this area space. You can read some of them. And it will guide you on how to plan the topology of these agentic AI workflows. So I think most of you guessed it correctly. The short answer is teamwork. And think of these prompts, little prompts, which can think small, tiny thoughts. Think of them as small children. They do not have all the skill, but they have one skill. And you bring them together as a team and you put them in a specific topology that you carry out this task, you hand over to this person will do that, and other person is just observing. So you can get multiple different thoughts. And that's really how orchestration of agentic AI happens. There's a question by Chandra. Is this strategy applicable for prompting and routine use of chat GPT? Chandra, that's hard. I'll tell you why. Because when you are talking to chat GPT in a browser window, there is one session. So you are giving prompt and you are getting answer. Effectively, from agentic AI way of thinking, there are two agents. One is the LLM and second is you. You are telling it to do something, it does something, and you have a skill and you review it and you are giving feedback and you're asking it to fine tune or make changes in let's say you ask it to generate a definition of agentic AI. And suppose it come up with a very long and a very complex definition of agentic AI. Then what you can do? You can tell it, can you please simplify? It will then simplify for you. So effectively, there is one brain coming from LLM and there is one brain of your own. There are two brains working against each other like a teamwork. Effectively, after 5 minutes of session, they have generated a value that you're able to understand the concept. So idea is to do the teamwork of these multiple agents. So your question that can this strategy be applicable in prompting? No, that's a short answer. For prompt engineering, there are many, many more techniques such as self-consistency, meta prompting, data-driven prompting, whatnot. There are plethora of techniques for prompt engineering. In fact, there can be a more than 1 hour long talk on prompt engineering itself. It is such an interesting world out there of prompt engineering. Okay, Sahil is saying, sir, how do multiple thought blocks represent step-by-step reasoning? So let me take the same example that I was saying, right? One is when you want to, given a PDF, when you want to teach that to your students to your class, you first want to arrive at learning objectives. Then you want to group the topics of how, then you want to create a sequence of those topics. And then you want to put bullet points against each of the topic in your PPT or your slides that you want to teach. And you are asking LLM to do all of it. These are multiple steps that I'm telling you. If they are part of same prompt, you try it yourself. More often than not, it will make many mistakes. But if you write a prompt only to generate learning objective from the PDF, nothing more. You write another prompt to only identify the topics covered in the PDF. That's another prompt. Then you write third prompt only to describe bullet points on each of the topics as a third prompt. Let's just say 3 of them for argument's sake, right? If you have 3 different prompts, we are talking about thought chaining as shown in the bottom, rather than one prompt, right? But that thought chaining, the example that I gave you, will result into a problem, because if the first one has made a mistake, the second one will, if the learning objective itself is wrong, the topics identified may also go wrong, etc. How do you break that pass? By introducing, like I said, different roles, such as a reviewer. When you generate the learning objectives, you create an agent that can review the learning objectives. Here is another very interesting example, slightly away from academic world, a real world scenario. I know you all want to hear from me real world industrial use cases of agentic AI. Many banks that I sometimes get a chance to speak to in the US, they tell us that they receive hundreds of fraud complaints every day, hundreds of them. Every bank. Let's take the example of a payment gateway. And sometimes the quantum of money that is involved in the fraud is small, like $20, $100, $200, etc. And I cannot give you the numbers because those are some confidential numbers. Those numbers change from one bank to another. And you know what these banks do? If they were to analyze every fraud, if it is $100 fraud, and if they were to put people to analyze it, the cost of analysis is more than $100. Because you have to, take into account the salary of the people that you are using for and doing the analysis. And you are having thousands of such reports every day from across the country. You know what these banks do? You call them twice, they will refund money in your bank account. Because by paying you $100, number one, they have a happy customer. And number two, they have saved their cost of not needing to do analysis. And that's why so many fraudsters get away by doing low value frauds. See, understand the reason why they cannot analyze, right? It's like this. If you have a 100 rupee note, will you buy a 10,000 rupee locker to safeguard a 100 rupee artifact? Doesn't make sense, right? You will not spend 10,000 rupee to safeguard 100 rupee. It's a very similar example over here. And that's how the world runs today. But I want to ask you all a question. Can agentic AI do this? Can it analyze, did the transaction actually happen? You are saying you paid to the, let's say you went to market to buy vegetable. You are saying I paid, and the shopkeeper says I did not receive the money. And now there is a conflict between two of you. You are showing your phone, see, money has gone. And the vendor or the merchant is showing his or her phone. And they are saying that the merchant says that I also have not, here it is, I have not received. And you're saying my money has been deducted. What do? You make a complaint. What will bank do? They will pay either one of them and not do the analysis, because cost of analysis is very, very high. And that's the truth of the matter. I know you won't believe. It's hard to believe, but that's really what is happening. With credit cards, that's so rampant. Agentic AI is here to solve such problems. We can build agentic AI agents that will go around, that will look at these emails of fraud report. They will log into your ERP systems, go with the trail that this money went from this place to this place up to this point. This is where it has broken. This is what happened. And this is where the money has finally landed. And then you can generate a trace and understand it and effectively have those losses those banks have to incur, they can be contained. And that's a very, very high impact use case of agentic AI. There's some more questions coming in before I proceed ahead. Chaitali says an interesting question. Can it solve daily educational problems like attendance issues, assignment, tracker issues? Very nice, Chaitali. So, yes, it can. That's a short answer. I know my own PhD guide, Dr. Gautam Shroff, he's nowadays a professor in IIIT Delhi, has built a system where his students submit the assignment and the AI evaluates the assignment for them and gives them guidance. And he's using that. He wrote that system himself. So yes, the short answer to you, Chaitali, is that it is feasible, and some of the professors are doing it, and in some cases, some universities are, because it requires special skill to build it. Some universities are investing money to get such systems developed to enable their faculty to carry out these tasks more efficiently. Particularly, I'm aware of such work, some of such work happening in a private university in the UK. Similarly, in the US, I've heard some places. Indian education institutes, I have not heard very actively, but many people are trying tiny, taking small steps. So education is one of the most obvious use case of AI. So look at the teacher. I mean, I learned so much from ChatGPT. If I were to read a book, it takes me much longer, and I would ask, it will describe in my level of knowledge, and I can tone down, or I can stay, okay, I know all of this, run fast, or go to next step, whatever, at my own level. However, things like attendance issues, you need to build a software, people with deep learning there is an algorithm for counting oranges on an orange tree. Forget about students in a class. Just by a camera, you can just take an attendance yourself. You don't need to take an attendance anymore. Just take a photograph. There is a camera in the classroom. Who attended what? You can just do. All that can be done. People are using that in the industry. They're using it for various interesting use cases, such as, is every person wearing a helmet in the factory floor for the safety of their well-being? It will raise an alarm that if somebody is not wearing a helmet, etc. Let me see. There's another question from Sheena. Can we write these chains of prompt as one single prompt? That's really what I was trying to tell you. If you write one single prompt, it will falter beyond 3 steps, 4 steps. It will not work. And that's a limitation of these LLMs. They're not human beings. They cannot think and they cannot reason as much as a human being can. So that's a problem. And therefore, you have no other choice but to break it. Hope that answers your question. It can handle such tasks such as using prompt engineering, chain of thought, and thought chaining. That's a quite a correct view, Sahil. What's the strategy to get better results on prompts pertaining to research, for example, insight on research paper or a trending topic? Chandra, I don't know if you've used deep research. The deep research is offered in the paid version, in the free version of ChatGPT also. They have a limited this thing. And I remember during my PhD days, I think I took almost a full semester or maybe at least 4 months doing only the literature survey. Must have read, I don't know how many papers. Today, with deep research, it will carry out a comprehensive literature survey in half an hour. If you write an elaborate prompt, you give it, it will go through all the research papers available. You can give conference names and it will compare, contrast, group them, and gives you a very, very interesting literature survey report on, and that's something called deep research. It's available out of Gemini, Grok. Most of them offer it. You can play with it yourself. So I think deep research, I use it almost like at least, if I'm not wrong, at least 3 times or 4 times in a week is what I use. If I want to study a news area and I want to study, for example, are there any products available for something? It'll go search all the products available on the web, compare them, contrast them, strengths and weaknesses, and generate a comprehensive report in about maximum sometimes 20 minutes, half an hour, depending on how complex and elaborate your prompt is. It generates a report. Literature survey is one of the common things that I do even today. So Chandra, I hope that, I don't know if you've used it. If not, I will encourage you all to try at least once something called deep research. And it comes by selecting the plus sign or the triple dot. Yeah, Chandra has already tried it. We'll be happy to share experience. So quick time check. We already have 10 minutes left. Let me cover a couple more use cases and then we'll have time for question answers. I've covered this one. This is a study that I was talking to you about. This is actually coming from a real customer. And what we did in this case was, we take a PDF as an input and we create an e-learning course automatically in about 5 to 10 minutes. And generating interesting visuals for every PPT, every slide, engaging the users. I remember when we were working on this, you give a PDF on gastroenteritis, it will generate a course on gastroenteritis. If you give a PDF on deep learning, it will generate a course on deep learning. You give a PDF on safety protocol called lockout, tagout in a factory floor, it will generate. You give it a topic on law, it will generate a course on that particular law. I mean, in 5 to 10 minutes, elaborate course gets generated. And it makes learning so fast and effective that I cannot tell you. And it gamifies. And this is our real customer for whom we built this solution, right? How this happens? Like I said, Many machine learning based techniques, a lot of prompt engineering. We did semantic chunking, text summarization, identifying central idea of the text, grouping the topics, and using ML based hints on how to generate, Bloom's taxonomy and Merrill's principles are fundamentals of pedagogy. Image comprehension, closed loop learning, semantic search were some of the another components of agentic AI that we used. Semantic search, you will know already, I guess. If not, look at something called RAG, retrieval augmented generation. That is very popular in agentic AI and generative AI these days, called semantic search. Image comprehension, given an image, it can comprehend. And let me narrate a very interesting thing for you. And this will probably answer your question. What we did was, we gave a prompt to the LLM to generate an image. And we said, for example, let me just take an example. An eagle flying over jungle with deodar trees and with wings spread out, etc., etc. And it generates. You try this kind of prompt yourself. For the same prompt, you try 5 times. Every time it will give you a different image. You'll agree, right? But the example that I'm giving you is a very simple example. But on a real e-learning course, you want to show the liver, you want to show, gut of a patient, superimposed on a human body, demonstrating where the gastroenteritis can happen, where, that kind of visual you want to generate, illustration. Now, you have a very detailed illustration for a given topic. And as you saw, somebody wrote that LLM cannot even generate an SQL, leave alone generating a technically correct image for illustration. So what we did was, we generate an image, that is one agent, and let's imagine that it has 90% accuracy. That 90% of the time it gives you a correct image, but 10% times it does not. And then we used image comprehension. What it does is, it will generate a textual description of that image. It will not look at the prompt it was given to the LLM. It will only look at the image output and generate its description again in the text. And then now you have 2 pieces of text. One which was used to generate the image, and second one that was generated from the image. And then you give both of these textual descriptions back to the LLM and say that, is there any difference? And if there is, that means something is not right with the image. And then you keep going in the loop until you're happy. And second time you ask it to generate the image, you tell it that last time I asked you to generate, you missed out the jungle. Or you generated the jungle, but there was no eagle in it. Whatever the feedback is. Okay. And then next time it generates, and finally you get the right image. And that's another very simple example of how you make 2 agents work against each other and make it like closed loop thing. With that, I've got a couple more use cases, but I think in the interest of time, let me stop here and take more questions, because there are only 5 minutes left. So there is a question by Sahil. But I have a doubt. How do these accelerators work together to build a complete e-learning solution? Let me give you a short answer. It is not easy to, and that's why you need a company like mine to help you build that. But a slightly long answer, it is possible. It's an art. Just like a manager in a human team picks the right talent and makes them work with each other to get the desired output in a human setting. Something similar, not same, is the approach taken by you as the god of the small world, and you're trying to identify and create some new human beings, like new agents, and you're going to make them work with each other like a team, and who bring multiple skills, and they work in tandem with each other, in coordination with each other, in collaboration with each other, in a complementary manner, and then you get, it's an art. It's not so simple to create, but it is possible. Your suggestion on what topics on AI should we learn? Chandra, I would say, if you're starting with generative AI, the first thing you should learn is prompt engineering and various techniques of prompt engineering. And not only learn, practice them, use them in your different walks of life. Learn what is called RAG, Retrieval Augmented Generation. That is a key component of agentic AI solutions. And then learn this technology stack. There was a slide. So you can pick something from the left-hand side first, start building some agents, and then go for LangChain. It has a bit of a learning, there's a barrier learning. It's hard to learn a bit if you have not used a lot of corporate technology architectures. Go for crew.ai, is simpler, easier to learn, and has more control. You can try. So that's a thing I will suggest to you.
And if I may add a point that, as Dr. Puneet rightly said, that learn about prompt engineering. Our next session as part of this online FDP program is prompt engineering and chat GPT and its impact. So we have 1 minute where I will, if you allow me, I would like to thank you, Dr. Puneet Agarwal, for your time. It was a very interesting and very engaging session. I think we are getting some comments from the participants also. It was very engaging and it's an excellent session. Thank you so much for sparing so much of your time. We learned a lot, and I'm sure the participants also learned a lot, especially the real life examples which you shared on what is possible, what is not possible. I think the audience really those are the comments we are getting, very informative. So I'll request all the participants to give this feedback on the AICT ATAL portal as well, because that is also one requirement for this session, because you will get your certificates only once you give your feedback. So do please share it on the AICT portal, the feedback that you're giving here. Thank you so much, Dr. Puneet, for joining us.
Thanks,
And
Kamna, for calling me for this session. It's nice to learn from all of you and the questions that people are asking. It was wonderful. Actually, the questions that people asked made it interesting.
right, thank you so much. And with that, I'll introduce our next speaker, Dr. TV Gopal. He's a subject matter expert. He'll be taking the session on prompt engineering. Thank you so much, Dr. Gopal, for joining us.
That's
I
enough.
will,
Thank you so much.
I will just,
I'll get started.
yes, I'll just introduce you if you allow me. Dr. Gopal retired as Professor Computer Science and Engineering at CEG campus, Anna University. One of his research areas includes science and spirituality. He has expertise in computer science, software engineering, information architecture, usability engineering, and cyber physical systems. He has published around 85 plus research papers, 4 books he has written, and he has co-edited 11 conference proceedings. He is actively associated with many professional societies. He's an expert member of the editorial advisory board of the International Review of Information Ethics, the official journal of the International Center for Information Ethics. He was also serving as Director, Center for Applied Research in Indic Technologies, Anna University. We are honored to have you with us, Dr. Gopal. Thank you so much for being a part of this session. I'll hand it over to you now. Thank you so much.
Thank you very much. It was my pleasure listening to Dr. Puneet Agarwal. And as a matter of fact, I also know Dr. Gautam Shroff. who was his PhD supervisor. It was nice, but all this happened over a span of 70 years. It didn't start yesterday. It has happened over a span of 70 years. And it's very difficult to believe a technology and idea in the field of computer science and engineering has been sustained for 70 years. It's very difficult to hazard a guess what will happen next year. But then we are looking at a technology that has grown from strength to strength in 70 years, and let's see how we progressed. I'm an academic, and therefore I strongly believe that it's a good habit to touch up with the foundations as and when we progress. And whenever we have a concern, it's a lot more simpler to go back to the foundations. That's the reason why the lecture is structured slightly differently. And it's out of experience that I have had as a researcher and academician. So let's see. Certain things I agree with Dr. Puneet Agarwal, certain things I may differ, but as a gestalt, which we'll have to learn, we have to make sure that we go ahead and keep learning. The essence of learning is something that should stick to one's own brain, not keep on telling that the machine has learned. That's where we keep drawing a difference and a parallel on whether it's deep learning or learning, something that must be sticking onto one's brain. How to make it happen is a question. In the process, what we found is that we are not really doing anything original, really doing anything super creative as we claimed till recently. Till 4-5 years back, an idea was just cropping up and we were thinking that the best thing that have happened. I haven't come across such a thing that has been done earlier. A common statement that zooms in the classrooms. Today, in 2 minutes, I can tell how many people have done that exercise, how many scientists have worked on it. Where to position your own idea is becoming too obvious in a flash. Punch a few words into the machine and it will position your idea in perspective. The net result is an alarming realization that we are not really doing anything original. We are not doing anything really creative as we have been claiming. The chunk of innovation, the granularity of innovation needs to jack up many-fold. That's the real challenge we have. AI has happened. AI has happened over 7 decades. Now, can we jack up what we were calling as innovation 2 years back, 10 levels up, and say this is innovation? That's the challenge which we have to face in every walk of life, in every sphere of activity. Let me share my slides now. With that goal, I started thinking of a kind of a flow which I am presenting. You're most welcome to comment. I'm also seeing the chat as we progress. No, I can't see the chat. I'm sorry.
Sir, I'll request you to put it on full
Yes,
screen.
it is there. It is there. Full screen. I shall do that. And then we'll see slideshow is there from the beginning. That fine? Right.
Yes, yes.
And Ms. Kamna, please do help me out with the flow of the
Yes.
chat.
Yes, I will share the questions with you, sir. I will do that.
That's good. Well, that's just about what is the status. My first brush with AI began at Hyderabad Central University. That's early 1988. That's around 33 years after the term AI began to get into the profession of computer science and engineering. At that point in time, Central University Hyderabad started an MTech in artificial intelligence and robotics. One of the very first attempts. And though I was doing computer science and engineering, it was catching much of an attention because for starting this course, a Texas Explorer system was specially imported. The point I want to make is in 1988, there was a need for a very special machine to happen with these fields called artificial intelligence and robotics. A new building was constructed. The Texas Explorer was coming as I was passing out of the course, and they were busily installing that machine. and the course happened, MTech in Artificial Intelligence and Robotics. It's a specialized hardware, a specialized computer, completely different. Not many Texas Explorers were really sold out into India, but Central University got. What was it used for? Artificial intelligence scheduling for Hubble space. Somewhere, big calculation, a fantastic idea. You can always keep on arguing that there are 9 planets, 8 of them will make 8 bits, one is a parity bit. You can always argue that there's a computational model like that, but then we are talking about something that really happened at a scale. Space telescope, which people were finding it very difficult to schedule that. AI was necessary. So now you see, where was the machine? What kind of a machine was used in artificial intelligence and robotics, and what is the application? And today we are listening to Dr. Puneet Agarwal over the last 90 minutes, and what we are talking about something that's affecting us every day. It's a progress. There's a phenomenal progress. Now let's see what else has happened. I was extremely fortunate to have interacted with Dr. Raj Reddy, a Turing Award winner. As soon as someone gets a computer to do it, people say that's not what we meant by intelligence. That's the first challenge they had. If a machine can do it, it can never be called intelligence. But then we are doing something else. People subconsciously are trying to preserve for themselves some special role in the universe. That is intelligence. So now what is the challenge, immediate challenge that I am mooting? Whatever you called innovation in your mind, on your paper, on your desk last year, jack it up 10 times. That may qualify as an innovation which is creditable to you. I'm not making any serious reference to the patents. They are all coming into the flow. But anyway, that's what it is. Turing Award in 1994, the origins of American Association for Artificial Intelligence is nice. He was very insightful in writing up this work. He was one of the authors. And how did the AI begin? Ask a simple question. Can machines think? What we are talking about is a phenomenally brilliant processing. Is it thinking? Still an open-ended question. This question was there when Turing began his exercise. Just to be a bit more provocative, I'm asking that same question. What we are looking at is a phenomenal processing, multimodal data, any kind of data, anywhere. We are not daunted by the sheer volume of data. We are able to process it in a jiffy. We don't require a super specialty machine. We are all talking about applications that are close at our fingertips. Every day we want to do it. So many nice questions came. The proof of concept for machines thinking was initialized in 1955. Alan Newell, Cliff Shaw, and Herbert Simon's logic theorist. The logic theorist was a program designed to mimic the problem-solving skills. It was funded by R&D, Rand Corporation, Research and Development Corporation. It is considered by many to be the first artificial intelligence program and was presented at the Dartmouth Summer Research Project on Artificial Intelligence hosted by John McCarthy and Marvin Minsky in 1956. John McCarthy, imagining a great collaborative effect, brought together researchers from various fields for an open-ended discussion on AI, the term which he coined at the very event. John McCarthy coined this term AI. This particular event catalyzed research for next 20 years. That's a phenomenally brilliant task. John McCarthy has written a great report which you should read in original, and I'm thankful to Dr. Raj Reddy for sparing his time and documenting how everything came into American Association of Artificial Intelligence in a manner where it becomes so pragmatic. For 7 decades later, we are seeing a phenomenal progress. What is AI? The quest to build machines that can reason, learn, and act intelligently. Now, you please connect these terms to whatever I have spoken. The chat GPT will give you in 2 minutes. This audio recording is there. Push it into the internet. The chat GPT will tell you where it is connected. Try it in your own mind. Where are these terms? I spoke about learning, something that should stick to the mind of an individual, the brain, not the machine is learning. Intelligence, the machine can do it. Is it still qualifying to be intelligent? Reasoning, are we able to chain to arrive at something which is really verifiably creative, innovative on our desks? Got an idea? Can I verify it to be innovative, to be creative? Please connect these terms. So the point I want to make is it's not the keyword kind of a thing. We have to hunt for the big idea that is putting these words together. That's something which we need to look into. Gartner hype cycle, shortly before COVID-19, many things changed. It has gone through that spell of disillusionment, slope of enlightenment. Right now, we are talking about something called a GPU architecture, speech recognition. Everything is hitting a summit, a plateau. Anyway, coming back to the point, artificial intelligence, therefore, should be perceived necessarily as a multidisciplinary idea, brought together many disciplines, because what we are addressing is the most important question: can machines think? They're processing in a phenomenal manner. You don't need a super specialty hardware anymore. The applications are day-to-day applications. So therefore, I strongly suggest, please do consider picking on good mathematical statistical skills, good programming, machine learning techniques, data structures, big data tools. As Dr. Puneet Agarwal was mentioning, in 2 seconds, you'll get a course designed on this, a full-fledged program. That's something which you can do. Just put a few words into this. And yes, there was a question on critical thinking in the earlier lecture. The Age of AI and Our Human Future, strongly recommended book by Henry Kissinger, Eric Schmidt, and Daniel Huttenlocher. This is where we are talking about AI engineer. We need an engineering skill to draw a line, to make a correct compromise. Intro to AI, mathematics, programming, machine learning, data sciences, big data, deep learning, everything comes together. But then what we are banking on is a phenomenal processing speed. We have lost the daunting volume of data anywhere in our minds. It's just that punch a few keywords and lo and behold, you get a great answer, a fantastic answer which is so cogent. Literature search, knowledge maps, writing, citations, everything is happening in a zippy. So you present an idea in the form of half a dozen keywords and your paper is through. Just pick the correct tool. So many tools I have included. Dr. Puneet Agarwal is talking on medical also. PubMed is the first one. Literary maps, Quillboard, with the references, with everything, your paper is ready. Then what is it that we are talking is creative? What is it that we are talking is innovative? What is it that is learning? That is for the human, from the human perspective. Therefore, I have been looking at the stages of AI, artificial intelligence in science. First stage of AI was perception, vision, hearing. Second stage, learning. Third stage, deep learning. Fourth stage, generative, and hoping to move to be transformational. It is transformational when what that machine is doing is getting stuck in my brain, my mind. That is the goal of learning. The machine will learn. What can I do? It is machine learning algorithm is there. Deep learning, it will learn. It will tell me what it is. What we have lost is a fear of volume of data, gigabytes, unending streams of data, multiple people talking in different way. This is a perspective that I am giving. This is the way in which my PowerPoint slide has been made. And this is how I have been talking about the same topic. But then this particular generative AI rationalizes everything. It gives you a very nice, cogent essay with due references, links, everything in a flash. So what is it that we are there for? How much of it is really getting into the brain? So we have to quiz ourselves, challenge ourselves. How? By jacking up 10 times the complexity of an idea which we thought was a very good idea, presentable idea 1 year back. That will be positioned perspective. The traditional AI to generative AI is that progression. We have to focus on ourselves. We have to increase our creativity, capacity to innovate 10 times more. Historically, the computing tool was supposed to do that. Take away all that was drudgery like literature survey, collecting the references, citations. Everything is done in a flash. Dr. Gautam Shroff's machine that takes care of all these assignments is nice. Just look at it. His own program it was so nice. I was there in IIIT Delhi and I'm aware of it. So the point I want to make is it's all happening in a flash. The generative AI is imploring us, like much like the computer did, but we didn't do it the way we wanted to do with computerization. Please be careful. How much of it, how much of that exercise you are absorbing as a human, that is the transformational goal. Today we are only at generative AI. Transformational goal is still a long way off. So let's start with the first stage, perception. The process of acquiring, interpreting, selecting, and organizing sensory information, vision, computer vision, and speech. Two things. I'm not likely to read all the slides. They're all there with Kamna and team. They'll be hosted somewhere. So what is it that we were talking about? We were talking about building equipment that can mimic our sensory capabilities like vision and speech. Vocoders were there much before World War II happened. I'm talking about much before World War II happened. Speech was doing rounds, the radio broadcasting speech, original. A lot of work has been done on speech, speech processing, speech recognition, speech generation. Per se, we found that electronics, that's signals, processing of the signals, conversion of this sensory idea into a signal, electronic signal, manipulatable, workable. Same was the case with vision. Perception can be seen as a special type of categorization where the inputs are sensory data and outputs are categorical judgments. That is exactly what we did. We are able to judge. This is what has happened. This is what can happen. Dr. Puneet Agarwal was mentioning that AI-generated lyrics were presented to maestros. They could not distinguish which is what, whether it's AI-generated or human-generated. So we are able to make a judge itself as a judgment. The difficulty of the task comes from the need for multiple levels of abstraction where the relations amongst data items. Now, all this was happening, but happening at a level of abstraction which is very, very risky, hazardous, floating everywhere if we don't have a mathematical underpinning. What brings us to ground zero in a self-assuring manner, in a reassuring manner, is a mathematical basis. How many of us will do a program on an MTech program on artificial intelligence and robotics today? It's just there at your fingertips. Why do you want to do a program? Just go ahead and use it. But the commitment in using it is you are going to improve your creativity and innovation 10 times more than what you were thinking 1 year back. We never see things as they are. And perception process of an intelligent system is often influenced by internal and external factors besides signals themselves. Perception is not a pure passive process driven by input. That is where we have been prodding further, saying that perception requires a human. It is simply not a passive machine processing. Oh, this signal came, this I have processed and given. That's where we are talking about the distinction, key distinction that we are making between generative and transformative in the fourth stage. 70 years later, we are in fourth stage, but then we have not shaken out of the shells of perception in the first stage. We still have to build on it. Today in a Ziffy, we are processing multimodal, whether it is an image, video, audio, handwritten, hand-driven, nothing is a bother. The type of input is not a concern. At that point in time, the type was of serious concern. What is it that we are inputting? In AI, the study of perception mostly focuses on reproduction of human perception, especially on the perception of oral and visual signals done with machines, machinery, devices. different devices. Two perceptions were dominant, hearing and vision. Lot of time, lot of research has gone into this. Speech recognition, voice command interface, speech to speech translator. Maybe towards mid 80s, there was a machine called Diddley. MIT had produced a voice command interface, much like today Alexa is there in every household. I simply talk to the Alexa, it reels off whatever I want. Voice command interface, identification of the speaker. Very recently, I was a reviewer and an external examiner for a thesis on speech diarization. 10 people are sitting in the room. Can you find out who said what based on the recordings? Correctly, clearly. The answer is yes, speech diarization. This is a technology, but then why am I so confident? Because there is a mathematical background. Today we are presuming that mathematical model called LLM has attained a maturity which is so fascinating to keep us, agog. Acoustic, phonetic approach, pattern matching approach, finally AI. AI was proven to be much better. We are not talking about patterns, we are not talking about phonetics. I'm skipping these slides, but then they are the actual acoustic properties of speech. You can't deny that. There are phonemes, that's how I'm speaking, that's how you are speaking, that is how every speaker is speaking. But then what we did in AI is something which is even more interesting. It's a completely different approach. We are neither talking phonemes, we are neither talking patterns, we are simply talking about a way of looking at these things which are so important. The acoustic properties of phonetic units, highly variable, speakers with neighboring sounds. Acoustic phonetic approach has costed us a lot, took us a lot of time. Represents speech pattern in the form of mathematical models. What's AI approach? The neural networks. That's where the learning began. We learn. These are the samples. Keep training a neural network. The neural network is a much more down-to-earth, very simplified model for controlling with negative feedback neural networks. Simple. Very simple mathematical model, very easy to understand, appeals to what we normally think we are doing. When I'm listening to somebody speaking, what is active are the neural networks. And I do that without really bothering. Dr. Puneet Agarwal himself was telling that we are not at all good on grammar. Yes, agreed. I'm not at all good. Though in my school days, we were supposed to go through the Renan Martin, useful for competitions. Competitions are cutthroat competitions. Grammar, spelling, everything is marked out. And we lose in 1 mark, half a mark. Particularly, there was a grammar school in Hyderabad. They are very serious about all these grammar and everything. That school required Renan Martin. So the point is, we are not so good. But then today the AI tool is simply generating correct grammar, correct spelling. Everything is done. Spell check, grammar check was there, an integral part of Word for ages. Been using it. So what is the power of neural network? We realized that the mathematical abstraction, the way we are looking at the same idea called speech, need not be that complicated, need not be such an intricate idea. It is just a feedback backpropagation network, multiple layers of networks, simple mathematics, simple ways of looking at how a neuron fires and a network happens. Now, this is what was my very first publication in the Hindu that was called Mimicking the Neural Networks. Mimicking the Human Brain was the title of this article, and it was published in 1988. I persisted with my research in neural networks for some years. I was working at Asian Institute of Informatics as a research associate, and then it was touching a plateau, and I just passed it on to people who went on to work. My research scholars started working on software agents, which is now in the form of agentic AI. We have now no more concern about the volume of data, the processing required. It's all there. The power of processing is also there. Kamna, you can interrupt me whenever there is a question. Speech synthesis,
Sure, sir.
translating.
Will do.
Yeah.
So
Translation.
we have asked everyone to put the questions. So uh, when
Okay.
there is a question, I will let you know.
Excellent. Thank you so much.
Yeah.
Now came, it's not recognition, it is text to speech. I've been working with people who are differently able. They need screen readers. It's a live example. I had one gentleman, Jagdeep Dangi. Even yesterday, I was referring to his work. You have to, what comes on the screen, they can't read. They're differently abled. So what comes on the screen must be converted into speech, and that speech in a different language. ITIL, Information Technology in Indian languages, covered by CDAC's work, has been so useful in this exercise. You have text, it needs to be converted into speech. So what's the concern here? The concern is AI has given us an approach where it's very pragmatic, simple mathematics, simple formulation. More importantly, it is amenable for the software approach. You don't need a hardware, you don't need to reconstruct a brain or think of how the human brain is working. A major remaining problem in all this is naturalness, especially context and meaning. Well, there are hallucinations, there are some pitfalls. Generative AI is not perfect, there are pitfalls. How will you know? It's the same case as a common joke that we share. A student was seriously preparing for an examination. He was 100% sure that the question, the essay writing question with maximum marks will be on Taj Mahal. So he wrote an essay for himself, mugged it up so much that he was absolutely keen on going to the examination hall, completely confident. So he went to the examination hall. To his horror, he found that the question was write an essay on cow. The fellow is completely convinced that it will be beyond him. Suddenly he got a brainwave. Once upon a time, there was a cow. The cow was in front of Taj Mahal. Taj Mahal is like this, like this. What's wrong with this? How do we evaluate? Why do we generate? Can anybody find out what is wrong with this? Can anybody comment in a metric manner what went wrong with this? There was a cow. Once upon a time, there was a cow. It's an essay on cow. The cow was in front of Taj Mahal. Rest of the story is what he has mugged up. The generative AI is not devoid of all this, but it's doing brilliantly. Fascinating work. The LLM model is serving so well. Music perception and composition are also studied in AI. There are a lot of good articles. Kamna has been so nice in putting me through to that Future Skills platform. I went through each and every module, the 33 modules. Some of them are only leading to other link modules, but 33 modules. I strongly suggest that each one who is attending go through that module by module before the next session, my next session, 9th October. It's very nice. Vision. Vision begins with a large array of measurements of the light reflector object surfaces onto the eye. Lot of study has happened. Eye recognition, eye tracking, how the light goes and processes it. It's necessary maybe, but then what we have done is we have simply made it capture information such as location, contrast, sharpness. Computational vision does it differently. Computer vision, computational based vision, dynamically change the scene. A lot of changes have happened. Again, the neural networks. So what we started as the first stage, perception, gradually moved into what is called learning, the second stage. Learning based on what? Strong mathematical models to give machine learning, easier mathematical model, but highly flexible, highly scalable neural network. Thousands, millions of neurons can fire. The volume is no more the concern. The processing speed is presumed. We don't need anything more than that. But then what is learning is a bigger question mark. So we found good representations, 3D forms, shape forms. We found a way of analyzing it, pattern recognition, hierarchical learning methods. CAPTCHA is everyday use. Good example is CAPTCHA. We see that CAPTCHA images, find out how many images have traffic lights, how fast it is. 2 minutes. It was taking a lot of time in 88. I still remember doing those rudimentary exercises on Texas Explorer. It's not so easy to get that vision done. Today, CAPTCHA is 12 images are coming, out of which how many images have a car? Need not be a full car. You take 1 minute, the machine takes 1 minute to conquer. It has the same way, same processing power. Vision is not a pure input process. Eye movement, active vision. So what we are talking about is, please understand, computational audio, computational vision. Please don't forget using that word computation. We are far from naturalness. Therefore, when we move to the next stage, we have improvised, definitely. We have refined, we have advanced, better algorithms came. But then where is that naturalness? Where is that comprehension that comes? Even without speech, we understand one another. There is no need for a vision input. Where is it? Where is it coming from? Provocative, slightly making you think that you should jack up 10 times more. Higher level perception. These are all matters of serious concern, multiple layers, contextual. Bringing context into this exercise is still a challenge. On 15th October, I'm doing that talk on contextualization in data spaces. It is still a challenge. We are still working on that. It's a conference in Tokyo. So we move from all these because we know that what the brain is doing is learning. Once it is fine, maybe it is doing like this. Second time it is doing like this. Next it is doing something called learning. See how we progress to second stage. From a focus on perception, two perceptions, hearing, vision, computational, computation. Everything is computational, compute engines. So second stage of AI started focusing on learning. Now please understand, today we are talking about AI with a perspective of 7 decades. 7 clear decades. It didn't happen overnight. So what we need to understand is the same: artificial intelligence, machine learning, deep learning. The learning phase was machine learning, completely bound to a chain of reasoning which is verifiable, mathematical, completely verifiable, completely understandable in terms of that kind of learning. I have given this much of content. This is what the machine is able to do. Is the machine learning and is it verifiable? So something which is not being presented, but it found on its own. That's learning. We have almost mixed it up with thinking for some time. Please go through the historicity of AI. It's all the same. Machine learning is a subset of AI focused on algorithms that can learn patterns of training data, make accurate inferences about new data. Inferential. It's not direct, it's not explicit. Learning is something that's not explicit. You may not be able to find that clearly written like what ChatGPT is giving now. There is a gap. Say, for example, Gestalt learning. Dr. Puneet Agarwal mentioned something. It's reinforcing to some extent, but I have been differing a bit, slightly a bit from what he was present. The central premise of machine learning is that if you optimize a model's performance on a data set of tasks that adequately resemble the real world problems, it may be used for a process called model training. So it is all dependent on a training data set. Today also we are doing the same. Now what ChatGPT has done is the entire world is having training data sets in that topic. I don't have to sit down and collect a training data set, train a model, and do LLM is just there. Large language model. In any model, any format, it can be there. The data set is unlimited. Unlimited number of parameters. We have computer time, supercomputer time being purchased at $10. So we have been talking about many of the projects that have been there in the last 5 to 6 years are all dependent on data sets. They are data sets. You can download the data sets, train your model, go ahead. LLM is something which is so generic, so fascinating, generative idea. Machine learning taught us two methods: supervised, unsupervised, very dominant. and then a reinforced learning, which is what we have been talking about as verifiable. So many types, so many methods are there. Logistic regression, decision trees. This is now fascinatingly well-established field. But this is what is learning. What we are aiming at is something that sticks to the brain, has huge data sets. LLM works on huge data sets, no limitation on the data set. In a Ziffy, the processing power is there. Supervised, unsupervised, most common. Reinforced, it's there in one of the modules. Please do read it. I strongly recommend that you complete the first few modules. So from machine learning, which is like this, rigorous mathematical model, to what we said, let's bring in chance. Deep learning, third stage, subset of machine learning driven by large, or rather deep artificial networks emerged over past. That's largeness, large language model, infinite neurons. It's not even, imagine that the infinite neurons, like what the typical brain talks. We don't know how many neurons are there, but we know large number of neurons. For any given act, only a few hundred neurons are involved. Out of billions of neurons, what we think is a very, very serious act, lifting the mouse pointer here to click, is a complicated, it was a complicated task. When the AI was beginning, we were talking the same. If we have to tell a robo how to pick an object and keep it, it's a program that will take 1 year to develop. Accuracy, precision. Today, all this robotic surgery is happening. I was listening to a talk the other day. They were talking about robotic surgery as an example. Input layer, no, the point I want to make is this is a phenomenal progress. Before we came to generative AI, we didn't do this overnight. It happened gradually. We did not shake off all those earlier lessons. When in doubt, you will always be able to go back to the foundations. Perception, from perception to learning, from learning to deep learning, each a subset of other. And then
Dr.
now,
Gopal, there is a question, if
yes,
I may
please.
interrupt.
Yes, please.
The question is from Prabha Shashikumar. The
Yes.
question is whether accurate interference is created by AI. If yes, which is like pseudocode or which is random? That is one question. And her second question is what is random interference?
Is it interference or inference? Prabha?
She's written, Prabha, is it, you can type, if is it interference or inference? Whether accurate inference is created by AI, is that your question? She is typing.
Okay. Good. Into the chat. I am reading the chat. Nice question.
Yeah. This is the question and answer chat box.
Okay.
I have asked the participants to put all the questions in the question and answer box and not chat box so that we know the questions.
Okay. But where is it? I am not able to see it on my machine.
Question and answers is if you see at the bottom, there are some tabs. One is a Q&A box.
Yeah, in the beginning I saw it. I was there seeing it. Yes, Q&A came. But suddenly after the PowerPoint was shared, I see that entire thing going to the top. And Q&A is now in the more set. Anyway, that's good. That's inferential learning.
Yes.
Neither Kamna is seeing my screen, nor I am seeing anybody's screen. But then what I found for myself is what is called inferential. And what I am seeing is Prabha Shashikumar. Zoom is tracking. Where is the question?
The question is interference is created by AI means will it take high bandwidth?
No, it is not. It is not at all a high bandwidth at all. We are now presuming that high-speed networks, software-defined networks are always there. On the software-defined network, it comes in a Ziffy. Say, for example, I was with the Open Power Consortium, and I had a login to the physical machines, super computing machines in Oregon State University. And I could just feed a query here, answer comes in a Ziffy on a rudimentary desktop, not so rudimentary. My university was good. I got a good latest Pentium. It goes over the network, goes through our server. Again, not completely secure server, but it goes. It comes out in a Ziffy. The actual task is being carried out on a cluster of 4 supercomputers physically located in Oregon State University. Does it answer the question? It's a practical idea. You can hire my students do that. LLM, those who are working on LLM, they have always purchased supercomputer time for $10. You can purchase it. It comes across the bandwidth. It can be demonstrated live. Is that clear?
Prabha, you can answer if your question is answered. Please answer.
It is not taking high bandwidth. It is doable even now. Yes, Prabha?
Yeah. Yes, she is writing okay.
Okay, good. Thanks. Thank you so much. Nice question. It's important to understand that the physical location of the machines is of no concern. Because I'm a researcher, I am looking for Open Power Consortium 4 supercomputing clusters. If you're not a researcher, it just comes in a Zippy. You don't even need to know which is the machine, how many servers are in the loop. It's not at all necessary. It doesn't take so much bandwidth. It doesn't take so much time. On a 586, in a typical university context of the bandwidth, answers come in a Ziffy. Computation happens in a Ziffy. You can almost live participate. Open Power Consortium was conducting a lot of interactive seminars, participated, presented my work through several meetings. That's a useful idea. Good question. Systematic literature review. Introduction to generative AI. Now comes generative AI. What we did is we simply started looking at a chat GPT, AI, machine learning, deep learning. Until then, we covered 3 stages. Now, the 4th stage, generative model identifies data structure. It's a big question. Smart data structures creates content and answer. So what we think is when you put something into the chat GPT, it will convert it into a questionable or a question which is well structured. Dr. Puneet Agarwal has given some good examples. Tree, the elephant jumping from a tree. Please use that example. You will find out how it will get structured. That question, which is simply a few words coming together, will become a structured query and creates a content in the form of text, pictures, audio, and video. That's fascinating. Audio, video, they are all drawn from the lessons when we learned in the first stage of AI perception. We didn't throw it away. We built further. We have simplified the model by having neural networks. That's learning becoming outside a subset of machine learning in the form of neural networks. And that gave us a phenomenal plasticity. The output can be text, pictures, audio, video. So what we did is we have done a brilliant task of carrying forward the work done over 7 decades, and now we are seeing the result of a generative model which tells that you just put a few questions, few keywords, and we'll get an answer in a Ziffy. That's what we have been doing. Write a letter. Write your text here, add a detailed description, and lo behold, it can produce new data based on learned patterns to create images, audio narrations, or text. That's it about. And prompt. What is ChatGPT prompt? An AI prompt is a text command written in natural language. All of us are aware of prompts. OS is a big chunk of software. Command prompt comes. Just give a command. Instead of giving a command, We are now talking about a communication in natural language. That's the prompt. That's a great idea. People were asking a lot of questions on prompt engineering. Which is the prompt that gives me the best outcome now? Now the game is different. We are no more constrained with the keyword, with the command word. Nothing is a constraint. You can toy around. Try this example. If I give this set of keywords, this is the outcome of the chat GPT. If I change the keywords, same concept, how will the chat GPT come? Play that. You create 2-3 models for yourself, then you would understand. Please remember, we did not throw away the lessons. We simply built in 70 years to come to this stage. Now, what we are asking is prompt engineering, which is the most optimal prompt that will give me the best results in a quick time. Some of my project work students have been doing this. It's a good exercise to talk about. They hired computer time. They have to go into the LLM, large language model. Some LLM they have to use. And then they purchased computer time at $10, push this large language model, and you will get different prompts: visual prompt, audio prompt, speech prompt, text prompt, combination prompt, different keywords, different modalities. It's an exercise that can be done. Prompt engineering is a way to get optimal results. Which prompt will give me the optimal results? That is where it is. The human is giving the prompt. This is where we think it's just about scratching the surface of the goal of the fourth stage. That was transformative. We are nowhere near transformative. We are only generating. Large corpus of data set is there. Huge computational power is there. Unlimited bandwidth is there. Toy around with the prompts. See what the chat GPT tells. That's what we are attempting to do. So NLP tools, comparison, chat GPT 3.5. There's a nice module. Gemini, Copilot, all these are picked from the modules. I just put it up in form of a tabular form. Out of 33 modules, all of them are there. Copilot is covered, Gemini is covered, Chat GPT is covered. There's a prompt template. Of late, we are getting some good templates for the prompts. We can as well put those prompts, category explanations, put your text here. This is the place for your description. Now there's a way of processing templates. Templates have been there for ages. We have been talking about all those templates. So what is the outcome of 7 decades? Text editing, reference management, bibliometry, content analysis, text editing. Everything is done in a Zippy. And what is that text? Can be any language, multilingual. We can always give that. So many years back, I was there with the Google Developer Days. There was a mention in the earlier lecture of Google Translate. I have seen it in the rudimentary stages. The good presentation, good team interaction, Google Developer Days at Bangalore. And this kind of a translate is just beginning to happen. The fascination, you give one language, another language comes. The script is done, everything is done. I happen to be knowing the team, particularly Jocelyn Becker, who was with Google at that time. And now take, for example, these ideas. Type any, point out. Now the point is you can simply take your mouse, point to a scientist image. Leonardo da Vinci is my choice. Get an essay on Leonardo da Vinci in a flash. How much you want to know, you'll get no more search engines, 1, 2, 3, all nicely done. An essay is coming. Copy the text and you got the essay on Leonardo da Vinci. All that you have to do is simply take the mouse pointer like this to Leonardo da Vinci and you get an essay on anyone you can choose. How correct are they? How will you know? Leonardo da Vinci is there. Einstein, everything was attributed to Einstein for the spell of time. Particularly during the World War, He was the only man who was sticking his neck out. Everything was traced. And all is fair in love and war. But I'm not taking the sheen out of this Nobel laureate. But then, for all right reasons, his Nobel Prize is for piezoelectric effect and not for relativity. Only one person knew theory of relativity, and that was Albert Einstein. And everything was banking on theory of relativity. The atom bomb was banking. The people moving all over the world was banking on Einstein's theory of relativity. And only one man was there to guide them. They were lucky that Einstein was there when the war has happened, though he was an active votary against war. Anatomy of literature. So much of literature, today you talk about forms. There are so many types of literature, ballads, blank verses. I never knew that there are so many forms of poetry. It's not simply poetry. I was reading through that module where automatic generation of poetry was covered in the Future Skills platform. It was nice. Kamna was so nice to give me so much of preparation material. I thought this will be useful. So many forms of poetry, not merely poetry. So many forms. It's not merely a test for a maestro to find out whether they can recognize machine generated and human generated. It's all there. Not only poetry, types of poetry. That is the next level of talking. We are only talking about lyricists. We have to do more. So this is the progress which we have had. Artificial intelligence, which started like that, intelligent machines, can machines think, is still a puzzle. We have somehow gotten deeper and deeper into learning, deep learning and LLMs. That's only a part of artificial intelligence. ChatGPT is only part. We wish that we will go to the next step. Transform myself into thinking 10 times what I was thinking as creative idea, my own idea 1 year back. That's transformation. That's what we attempted in computerization. Take away all the chores. Then the human being will have the potential to improvise on the human potential 5 times more. But that didn't happen. We got saddled with computers. It is up to us. We will have to position this technology, take a call on it, and we are doing a great job. At the end of it, we are talking about making people understand this. It's very important to make people understand this. Such courses are very, very useful. 30 transformative applications of generative AI are possible. Name anything. Telecommunications, smart cities, media and entertainment, any number of examples can be constructed. 3.0 was something that we did it some time back. Content generation, marketing, customer service, supply chain. Some of these topics have good notes on the Future Skills platform, the course material. Education is supposed to be covered now. How much time do I have, Tamna?
So we have half an hour.
Excellent.
We have almost 35 minutes.
Very good, very good. So this is where the transformation has to begin. So far, what was happening? Generating. What we are talking about? Generating. How did it happen? 7 decades. What's the foundation? Perception. Perception limited to only hearing and vision, speech and vision. But human perception, as you know, is something much more phenomenal. Then we moved into a subset, learning. Another subset, deep learning. Another subset, LLM. So we are operating at a very, very highly impactful, most certainly highly impactful, the most impactful by far, LLMs, which is a super subset of what we attempted as AI. When the complete AI comes, then we will have a transformational idea. The human is progressing. The human is improving. In a flash, what the generative AI comes, where is it connecting to the transformation? One idea, as I'm presenting on October 15th in a conference in Japan, Tokyo, is contextualization. Can we bring the context? In the world of computing, we have thrown away the context first. We are talking about context-free grammars. whichever language you talk, whichever programming language you talk, we talk about context-free grammars. Having knocked out the context, we have gone closer to the machine. But transformational is coming closer and closer to the human to make him jumpstart, to make him realize, to make him rationalize, to make him or her reason that this is what is the best bet which we have. Hoping to be transformative, we need a maturity model for Gen AI. Gen AI is good. All of us can exercise our minds on variety of prompts. Fight with one another. My prompt is better than your prompt. We can talk. We can get tools to tell us prompt engineering. We can cascade prompts. What earlier speaker was mentioning thought. We can cascade prompts up to a level 1 or 2. We can chain them. But then what is necessary is a maturity model. I draw lessons most of the times from what Humphrey did for software, capability maturity model. And this is something which I would strongly advocate. Gen AI is catching the eye, making all of us feel that we should know. Some of my student projects in the last 1 or 2 years did trial out on LLMs. Not so much on prompt engineering, prompt construction, but LLM per se. Now, it doesn't, as I said, volume of data is no more a daunting idea. Computational speed, no more a concern. You can get your tailor-made computational open power thing. I don't need to import a Texas Explorer anymore to start an MTech. Neither do we want people to do an MTech in AI and robotics. But then the fact is, we need to have a maturity model. Otherwise, whatever I generated. There is no time to compare. I'm going ahead with it. How confident are you in what this Gen AI generated? Is it clever copy and paste? Or are we becoming lazy enough not even to do copy and paste? There have been automatically generated research papers. It's not a new idea. A couple of students in MIT have produced an auto-generated research paper. Now, the point is, it is something which we must wake up to. Each time you are using a chat GPT, I'm also thinking the same, that what I thought was a good idea to pursue 1 year back is proven to be a beaten track, which I didn't know. Unless I make it 10 times better, I may not stake a claim as an original idea. What will happen to so many patents, so many things, copyrights? Big question mark. Very big question mark. Future only will tell what are we going to position them as. Strategy and leadership, data and infrastructure, use case portfolio, all these the earlier speaker has nicely presented. A very good position. What is happening today? What I am trying to do is how it happened across a span of 7 decades. Please remember, any idea, any technology in the field of computer science and engineering has barely enjoyed this kind of a reputation for more than 1 to 3 years. 1 to 3 years is over. If it crosses 1 year, it's a great idea. A topic called AI is still there, and we are still telling it's a subset. We are only there. But it's catching attention because it is impacting every field, primarily to point at the fact you have to jack up your own creativity 10 times. Task agendas, agentic AI is there. One of my very first research scholars was doing on software agents. His idea was the same. He was having a corpus of text-based data and a corpus of different domains data coming together. He built a software agent that works on some environmental variables, what is necessary, what is happening. It was his PhD. He got his PhD. He was very fortunate to work with Professor Rajaraman in IISc. He got an internship. He spent a few months. Again, the emphasis was on verifications, validations. Strong mathematical model was necessary. So we had good Professor Vaidyanathan, who founded the Department of Mathematics in College of Engineering, Guindy campus, who has taken interest in this. It's a challenge. It's a mathematical challenge also. But then do we want all people to learn so much of mathematics? The answer is no. We don't want. At the same time, we don't want people to believe that whatever is coming out of the machine is correct. That's what is happening. That's what happened with computerization. Sir, the machine has given this, sir, it is correct. Who are you and I to challenge it? It's a fantastic machine, great software. It must be correct, sir. Don't please, let us not waste time. The machine was made to save time. Now we are all hazarding that potential possibility because it gives a very cogent essay. A very cogent essay on any set of words that you feed into the prompt. So prompt engineering is going to be a very big exercise. Good question. It is necessary to understand that. That is not enough. We want agentic AI. We want software agents to work on it. So let's move on to the focus topic of today. This is about ChatGPT, AI in education. Very good set of content is there on the Future Skills platform. I did everything. It's nice. Please do that. Much before I started preparing for this PowerPoint presentation, I'm definitely thankful to Kamna for putting me onto that platform right away. I completed everything. What I talk is something which is based on all that.
Thank you. Thank you so much, sir. And thank you so much for taking this session and doing the session and, creating so much awareness about the technology. Thank you so much.
Now, am I out of time or still time? Still some
No,
more
no, no,
time?
no. No, no,
Okay.
no, no. You still have 30 minutes, sir. Please go ahead.
Very good, very good, very good. We'll have a good interaction session at the end. I'm planning for it. We'll have
Yes.
some good question and answers. Past dinner time, I know it's past 9 o'clock. But then that's how things are happening now, all over the world. We are just there. Our problems are problems of scale. Suddenly, I want to make 3 million people aware of this chat GPT, its potential power, prospects, and pitfalls. On their own, they should be able to find it out. On their own, they should be able to experiment. Large classes, we are talking about it. Online as a response to scale. So the only way we could think of is go ahead, move online like this, for example. There's no upper bound. You can have many things. I myself did one MOOC during the COVID-19 lockdown. There was a mandatory requirement for our educational multimedia resource center to be open because it is connected to satellites. It is supported by ISRO satellites, EduSat, and that communication channel should be alive. We can't close it down. COVID-19 is a national crisis, global crisis. In crisis, all outlets, all licensed communication outlets must be open 24/7. Anytime any need may come, we were running Anna FM community radio with a good reach. A large number of people are covered. I wish that there was an AI tool that was allowing us to monitor, but it wasn't there. So the director of the center and one or two fellows who are around who are willing to take the risk used to visit that. Having nothing much to do, we started creating a course on object-oriented for arts and science. That's the genesis of this idea. Good examples from what I've been talking were picked up. For arts and science college students, a big student population. And we have to teach them OAD. It went through processes, the approval process for MOOC. But then what is the point of MOOC? Massive online course. Is it a solution? How many people are able to complete? How many people are able to take the question? The dropout rate is too high. It was well monitored. After COVID, we had 5 more. I was in service for 5 more years. So it was being broadcast. The video lectures were broadcast. Content was available. People were registering. It is not for engineering students, but deliberately made for arts and science colleges. That was the book which we prepared. It was giving me some satisfaction. that I can tone it down, make it happen, let them understand what are the pluses and minuses of what we are doing with some good examples. So we can be objective. There's a hope that everything can be objective, but look at this online as a response to scale. So if you want to suddenly go to 3 million people, is online the solution? May not be. ChatGPT is not a solution again. Multimodality is not a solution. More than 50 degrees are there which are just generatable. 50 degrees are generatable. The conversation about scaling, high quality, low cost graduate online education. Why? What is the reason why we are talking about it? Learning is not on the machine. Learning is on my mind. If I am learning, if I am inferring, it is me who is doing it. The machine is very fast. Today, the machine power is unlimited. The data sets are unlimited. Just give 3 keywords and you get a great essay. Point to a scientist image, scientist name. You'll get the entire work of that scientist. Who is proving? Who is verifying? Where is that verifier coming from? That's transformative. We are still generative. We can generate 50 degrees, which are offerable for millions. Engineering is having less number of students who are likely to study object-oriented. That was our premise. See, all of us write some proposal, which will be approved by the concerned authorities, and finally this got a nod. How to teach object-oriented analysis to students in arts and science colleges, large number of people. Very large number of students. So a degree program can also come in a flash. Tomorrow it will be a degree. So what is it that we are talking about is modality. Multimodal is not a solution. Scalability is not necessarily online. Then what is it? Therefore, we have to talk transformational. Affordable degrees at scale, new phenomena or new hype. Very, very nice paper. All details are there for the virtual event in 2020 on learning systems. Session 1, a great idea. 2020 was a rock bed on which everything online happened, tested. People were not even sleeping. People were really, it's the shocker. 2020 is the shocker. So those people who are really there, they're just giving whatever idea came, save lives. That's the concern. So this is a very rockbed conference, a virtual event in USA. Very good topic. Till today, the puzzle is there, the same puzzle. The same puzzle. Is it a new phenomena or new hype? What is it that we are going to do if I have to make, let's say, 3 million people aware? Is it online? 2 sigma problem. One-on-one tutoring, individualized instruction, immediate feedback, corrective action. Which is better? This is called 2 sigma problem. One-on-one. That's what it is. Socrates taught only Plato. Plato taught only Aristotle. One-on-one. Or just pump it into million people. Dilemma is still there. It's a 2 sigma problem, one-on-one tutoring. Status of higher education. This is no answer. I'm not trying to give an answer. AI is good at an awareness level. People get aware. Good ideas will come. Online awareness. How many people are attending? Attendance was a problem here. Dropout rate has been very, very high in MOOCs. People who are clearing the course is very less. Many dropouts. In the beginning, yes, a large number of people, wherever they are, whoever they are registered. Let's see what happens. I hope Kamna is getting all these statistics in for this course. Anyway,
Yes, sir.
7
So we
in
are
high
tracking.
school.
We are tracking, sir.
That's good. Status of higher education. 7 in high school grads start college, only half graduate on time. Only 7.3% single parents get a degree in 6 years, 46% dropout. Students delaying college after high school, 13.7 with a degree, full-time, 38 million working age adults, some college, no degree. That's the status. Promise of innovation is there. We have to reinvent this idea of higher education. Where is AI positioning? Transforming learning. That is the goal. Not merely learning, deep learning, LLMs. Subset of AI is machine learning. Subset of learning is deep learning. Subset of deep learning is LLM. But then what is it that we are gaining for? Transforming learning. Is it punching my brain, making it shoot up? It's something which we keep telling in a standard textbook. I was with Usmania studying electronics and communications. The first 10 problems in a standard textbook are no-brainers. Only if you are solving the 11th problem, graded exercises, 11th problem, then it is sticking to the brain. Particularly electronic devices and circuits by Millman and Halkias. It's a Bible. Till today, there is no book that can beat the impact on the human brain. The textbook has impacted all of us. Even in the dreams, we were telling the same. Millman and Halkias, chapter 3, up to 10 problems, no brain. The 11th problem after the chapter is the beginning of learning. How will Gen AI do that? Please think. Your answers are most welcome. Type it into the chat. The effect that one textbook, Electronic Devices and Circuits by Millman and Halkias, has produced on us is phenomenal. Till today, I remember that experience. None of us, we were all going to the entrance examination. We never bothered. Up to 10 problems is no-brainer. A graded problem, 11. That's the time when the learning begins. How do we solve those problems? How do we have those graded problems? Already we are having, I mentioned some statistics, some numbers. The essence is MOOCs is a solution for scalability. You can't imagine a classroom of 3 million people. You cannot imagine a classroom of 1,500 people. So very early days of his presidency, His Excellency Highness Professor APJ Abdul Kalam has started this multiple classrooms in 6 different locations, each location having 1,000+ students assembled. He started lecturing from Rashtrapati Bhavan. A great idea. But then the follow through, we didn't have this kind of an advanced platform tool. I'm enjoying this platform a lot. We know what we did earlier and where it was, where we needed a lot of reinforcement. But the very early 2003, 2000, maybe 2003, that 20+ years back. The great idea. He was doing it in 6 venues all over the country. Chennai had 2, my university and another university, 1,000+ students, and he was lecturing, taking question and answers from multiple sites. Idea was good. Idea is good. But then how many people can persist if it is a course, if it's a full-fledged program, the dropout rate is high, the pass percentage is very low. We can't help it. So is personalized learning an answer? This is 2 sigma problem. Personalization of this. See, I am interested only in music. Can the platform fine-tune itself to produce content of Gen AI on music only? The matter of fact, even though I have interest, I don't have time to do anything. My focus is on music. Everything that I am speaking is not into education, to music. Whatever I spoke until this focus section started in my presentation should be tunable to music and only music. Then 7 decades of progress in AI is teaching me how my domain of music is getting impacted. Again, AI was presented as a very big idea. Even now, it's a very big idea. Perception on hearing and vision had maximum impact. We are able to see it. Learning, deep learning, good progress. But learning on the machine, inference, LLMs, data sets unlimited, bandwidth unlimited, computing power unlimited. The model is having umpteen thousands of parameters, which was difficult earlier. That's generating. Learning must be something else. Student institute interactions, where are they coming from? Where is that human coming from? Please go back. This should be the goal of transformational. Keeping the human in the loop, both as a teacher as well as a learner. How do we do that? 4 Ds of robotization: dear, dangerous, dirty, and dull. I have had a good experience in Japan of a teaching robo. I visited Waseda University 2019, a teaching robo. Practically, we can control, we can do that. It's a great idea, but then it is dangerous in many ways, dirty and dull. How long does a paper need to be? Can it be double spaced? Is there an upper page limit to the paper? How do I submit the paper? Dr. Puneet Agarwal was mentioning it takes 10 days to read a paper. I'm writing a paper for the last 3 weeks. It is still there, but I enjoy writing a paper. And I want to make sure that it passes through all these plagiarism checks. That means it's not picked from ChatGPT. It's not picked from this. How do I submit the paper? Are we required to attend the online office hours? Can I get my degree plan approved? These are the questions. So we are now transforming curriculum and learning spaces. Impact of jobs, impact on curriculum, truck drivers, customer service personnel. We need to get them into the learning net. Absolutely necessary. There has not been a single idea called education that was so transformative all over the world. Phenomenal transformation. There's nothing to beat it. Every civilization, every country has acknowledged education has the maximum transformational value of the human. So if we can use this technology to get the truck drivers, customer service personnel, accountants, lawyers, doctors, just get on with the task. That's the future skills. They don't need a theory, they don't need a thesis, but they are skillful enough to understand something went wrong when it goes wrong. Something should tell me, my goodness, there's something fishy, something went wrong. Then I can consult an expert. How do I build that grade of skill? Not skill that simply tells I can go ahead just switching on a light. I'll simply switch on the light. For this, why do I need anything, anybody? When something goes wrong, how quickly can I sense? The Murphy's law, if anything can go wrong, it will. There's no second opinion about it. So what we have to define is a skill that is good. Go ahead and use it. But you should have that innate sense on oneself that something is slipping out. Even though it was just a matter of fact, like switching on a light bulb, something should make you uneasy. Something should prompt. This is a different kind of a prompt. Be careful. Something is not sounding well. That is skill driven into the human brain. Are we doing it? That's a question that we have to ask for ourselves. Where courses need to improve: natural language processing, safe learning, extreme learning, soft skills, curiosity, critical thinking. We called it critical thinking for some time, but that's not exactly what it is. It's an innate sense. Something is going wrong. The RHS and LHS are not balancing well. The right hand side and left hand side. There should be an instinct. That is when it got stuck to the brain, whatever is a skill. Teacher preparation, most certainly, have been greatly helped by all that content. I would have taken much more time preparing this lecture, but then the content is so nice, it's guided. Didn't take anything. I don't remember taking much from the 33 modules, but it is still there. Create content, deliver content, facilitate and guide learning, assess learning, instill curiosity, inspire critical. That is transformational. Not simply generative. The next leap is transformational. So let's look at the subsequent lectures from this perspective. 7 decades, we have now forgotten multimodal as a big idea. Images, vision, video, audio, any form, text, handwritten, typed, any language, any script, everything is over. Infinite data sets, potentially infinite computing power, unlimited bandwidth, just 3 keywords and you get a cogent essay. What next? That much is seen. That much is obvious. Toy around with prompts, prompt engineering. Which set of keywords will give you the best essay? Ask for yourselves. Which set of 5 keywords? I'll say, please choose 5 keywords. Which 5 keywords will give you the best essay from ChatGPT, the same ChatGPT? How do you rank them? How do you engineer so that the optimal essay will come out? Please think, please try it out, please experiment. Now, that is not enough. The job of a teacher is to instill curiosity, inspire critical thinking, encourage flexibility, reinforce collaboration, not merely team effort. It's a collaborative idea. Do it in practice. So, cultivating ethics, inclusion, and social justice. That is what is the most important third point that we are talking. I know I have another 5 minutes. I think I'll be able to do it. Diversification of education and workforce. 19% higher revenue due to innovation when management is diverse. Distributed learning. Work as an important tool of diversification. Learn while you work. You have a problem on hand, please learn. You cannot make all mistakes to learn from all mistakes. Learning is largely to avoid mistakes which others have done. The essence of learning. AI depends on diversity of data. AI in higher education, it's there. Who decided that? Administration, teaching and learning, student experience. I'm not going to read this out. But applicant reviews, chatbot support, CFPs, call for proposals, Puneet Agarwal was mentioning, in a flash, all CFPs are analyzed, studied. It was taking weeks for him. All that is understood. It helps in administration, it helps in teaching and learning, it helps in student experience. Generative AI in education market, learning platform, intelligent tutoring system, it's estimated at close to $2 billion. Fraud and risk management. But what is it doing? It is still giving you a faster way to disprove that what you claimed as your own idea is not true. That's all it is helping us fast. Thank you very much and discussions.
Thank you so much. Thank you so much, Dr. Gopal. If there are any questions, we'll take those now. We still have a couple of minutes to take any questions that you may have. So, Dr. Gopal has very kindly stopped his lecture so that he can take the questions. I will encourage you to ask your questions because this is the best time to gain insights from his experience. He's I'm not sure if this particular FDP is here because we are planning more FDPs, sir. If you are available, we'd like to invite you for those as well because I know you are
Thank you so
traveling to
much.
Japan and all. So I don't know.
Thank you so much. Anyway, the online is there. It's of physical location is of no consequence.
No, it will be online, sir. We are doing online FDPs for AICTE. We'll be doing more sessions.
I'll be happy to do that. 9th again we are meeting.
Yes.
And please let me know what
so there's
is
a question. There
Yes,
is a
please.
question. Please suggest some resources on Gen AI in research.
Yes, I have had a slide. I'll go back to that slide.
Yeah. So there's a question.
Is my screen shared again? Okay.
It's Chandra Kumar is asking this question.
Chandra Kumar has been very active in the earlier session also. Very nice
Yes.
questions. Very
Yes.
nice questions indeed. I have enjoyed that entire session. Very good questions. I hope we'll get more. No, not here. Maybe. Yes, I'm
So-
moving. I'm moving there.
Yeah.
Just give me one.
Yeah. So you can share your screen because now
Yeah,
you
this
stopped sharing. You
is.
can share again. You can share again.
Okay.
And one more question is, can Gen AI help in big data analytics?
Yes, of course, it does. That is where I have shared. And
Resources for Gen AI research. Yes.
yes.
You can go full
Ah,
screen, sir. Yes.
now it's full screen.
Yes.
You see, literature search tools are there on PubMed, Google Scholar, Elicit, Knowledge Maps, Grammarly is there, Zotero, Mendeley, EndNote. All these are helpful in research. Give any topic, you are absolutely there with any tool, all these tools. What we are doing as research is the same. We do literature search, then we find out what is your idea, put it in the context. That's a knowledge map. What happened before? What is it that is your idea? What is the impact of that idea? So there are three tools: Research Rabbit, Connected Papers, Lit Maps. Immediately you will know where is your idea. Literature survey, yes. Grammarly for writing. You can take help, Paperpal, Quillbot. Zotera, Mendeley, and EndNote for citations. You can write it to improve your citations. EndNote is very good. Personal citation bibliography manager. Mendeley. So please note there are about 12 tools for doing what? Literature survey, knowledge map, writing and citations. You have produced an international journal quality paper on any of those keywords that you are talking about. Good literature search, knowledge map, writing and citation. Is it what we want to call it as research? So please understand, my humble submission has been how much of this exercise on the machine is really getting imbibed by the human, and how much of that which got imbibed is scalable to 10 times more than what they started with. That is a challenge. That is a transformational value, which we are hoping.
So there's one more question if we have time.
Yes,
Can you
yes.
suggest resources for statistical graphs? There's a question from Chetali.
Yes, there is a Statistica package which does it. It will give you statistical graphs in a flash. I can give you that reference. Numerical processing, quantitative data analytics, big data analytics was the question. I'm doing that. Just give me 1 minute. I'll put it in the chat. Chat GPI and data analytics. I find how many tools? Data analysis with Chat GPT for data analytics. Oh my goodness, there's an unending stream of tools that are coming. Data analyst and report AI. My choice, the one that I have used is Statistica package. So you can definitely gain from a comparison between Chat GPT. I'm typing it into that. There's a Statistica package which you can work on that. Yes, I'm writing it to the chat. Is it fine?
So Yeah, it's fine, sir. Actually, we have some more questions, but I'll request participants to hold on to the questions. Sir is taking another session on 9th. We will take these questions at that time. There are some questions coming in, sir. Next time, maybe we can wrap up 10 minutes earlier to take these questions, because right now we're running out of time.
Very good.
I'll request all the participants, thank you for your time. I know you have questions, but please remember these questions. Next time, sir is taking the session. We will start, probably we can start with some questions, or maybe in the middle of the session, we can start with the questions after one part is over. So we'll stop now. And thank you so much, sir. Thank you so much for your time. And the very informative session, questions are coming again. More and more questions are coming, but we don't have time now. We will take it up in your next session.
We will
So thank
start
you
with
so
the
much.
questions. Kamna, can you please docket all these questions in the chat and we'll start answering on 9th.
Sir, I will try, but
Okay.
I'll request the participants to hold on to the questions and share in the next time.
Yeah,
That
I am
would be
able to
better.
save the chat.
You are able to save the chat?
Yes.
Okay.
Well, I'll take care of that. Okay.
Okay. Thank you so much, sir. Thank you so much for your time. Thank you, participants. Look forward to
Nice.
connecting with all of you tomorrow for the next sessions. See you all there. Thank you so much. Thank you. Bye, sir.
Nice.
Thank you.
Thank you so much.